Thank you.
College is often viewed as a mere institution, a labyrinth of classrooms, textbooks, and endless exams, where our future is shaped. Yet, when we step foot on campus, we realize that we are not alone on this journey. University transcends academia, transforming into a vibrant community where individuals unite. To learn from one another, to grow and to forge unforgettable bonds. It's not always about having a precise plan. It's not always about figuring out. It's not always about reaching the finish line first. It's about discovering what we are truly passionate about. The true essence of college, however, lies beyond the confines of academic pursuits. What truly makes college so special is the life that's lived within its walls. It's about seeing things from different perspectives, exploring unique possibilities, taking on new challenges, finding joy in friendship, embracing individuality, expanding our knowledge and skills, and immersing ourselves in extraordinary experiences. It's a path that teaches us about resilience, courage, and determination. A quest that allows us to pursue our goals with purpose and clarity. A quest that helps us find balance, happiness, and fulfillment. A transformation that inspires us to live with intention, curiosity, and joy. A trail that leads us to a deeper understanding of who we are and what truly matters. It's a journey of self-discovery. Every experience shapes us into the transformation of ourselves. College education. Experiences. Experience a whole new world of academic excellence in a global environment. Future many places today.
Dear students, thank you for watching the video. And dear students, I welcome to the Daya Season 3, 25th session. Today you are going to have first session, chemistry. In that, electrochemistry, redox reacting, chemical bonding, and basic concepts of chemistry is being discussed. Class is going to be 4 to 5:50. After chemistry, there will be a 15 minutes break till 6:05. 6:05 to 8, you are going to have biology of Pawan sir. Professor Pawan is going to cover class 11th or PUC first year part 1 revision. Dear students, now I'll hand over the session to chemistry by Dr. Ravi Shankar. Sir, over to you, the session, sir. Students will put their questions in Q&A box. Please check and have a look, sir. Thank you so much. Screen is visible, sir.
Dear students, as I told you yesterday, today we'll be discussing about electrochemistry and P block. So the first PUC revision, we will take it from next class onwards. Okay. So today we'll be discussing these two important second PUC topics. Because in second PU, as I told you, there will be around 45 questions. In first PU, there will be only around 15 to 20 questions. So we'll give more stress on this particular second PUC. So today also we'll be discussing about, as I told you yesterday, electrochemistry and P block. So coming to this electrochemistry, so what are the things we are supposed to study? Electrochemistry is all about studying about what? Conversion of chemical energy into electrical energy or vice versa, electrical energy into chemical energy. You know that you have two types of cell. One is electrochemical cell. What is electrochemical cell? Where you're converting chemical energy into electrical energy. What is electrolytic cell? Where you're doing opposite. You're converting electrical energy into chemical energy. So when you come to electrochemical cell, that usually you've already studied about what? Daniel cell. Daniel cell. And what is Daniel cell is made up of? So it's made up of zinc and copper. It is made up of zinc and copper, that you know that one. So you'll be taking a zinc as anode, and it will be kept in a zinc sulfate. Then you'll be having a copper in a copper sulfate. So these two of cell, you know that one will be connected by a salt bridge. Will be connected by a salt bridge, and the two are connected through external circuit. And these two are connected by a salt bridge, you know that one. We call it as a cell. And we call it as electrochemical cell or Daniel cell, which can convert chemical energy into electrical energy. So usually zinc is the one which is called as anode, which is on left hand side, and copper is on right hand side. And here reduction takes place, remember, whereas in anode there will be oxidation. Oxidation. It is a negative electrode, and whereas cathode is a positive electrode. So why we call it as oxidation? The metal loses electron, and here metal accepts electron, so it's reduction. The overall reaction is that zinc acts as a reducing agent. It reduces CO2 plus into copper. And this cell can be represented as zinc, which has been kept in a zinc sulfate solution, and through a salt bridge they are connected, present in a copper sulfate solution. Please remember this one. Very simple trick is to just remember the keyword lone. What is lone? Left hand side, if it is anode, oxidation takes place, the anode, and it is always negative. And once a cell is known, you know that you can calculate E naught of a cell. How, sir? By taking E naught of cathode minus E naught of anode. Please remember this one. E naught of cathode minus E naught of anode. We can also write E naught of a cell is equal to, sir, E naught of a right hand electrode. Right hand electrode means it's a cathode, minus E naught of a left hand electrode, that is anode. And how do you know, sir, E naught of each of these particular anode, select, and cathode? We can calculate the E naught of every element, okay, by connecting with She. There are two types of electropotential. One is oxidation potential and reduction potential. Oxidation potential means where the metal is losing electron. Reduction means where the metal is gaining the electron. So how to calculate this E? As I told you, we can calculate E, okay, under standard condition. At 25 degrees Celsius or 298 Kelvin at 1 knot atmosphere, then we call it as E naught. Otherwise, it is referred as E. That's it. How we calculate? By connecting with She. She is taken as a reference electrode, or sometimes we also use caramel electrode. These are called as a reference electrode. And their electropotential is taken as 0, 0. And by using this, we can calculate what you can call it, electropotential of all the elements. If you can see it, given a series that we call it as the electrochemical series. If you observe it, hydrogen where? Here it is hydrogen. That is taken as 0. 0. And when you calculate, you may get positive also, negative also. So what do you mean by the negative? If you get a negative, that means you are ready to give electron. You are to give electron means, sir, you are a very good reducing agent. So you are a very good reducing agent. Whereas if you get a positive, that means what? You can accept electron. So you will accept electron. What do I mean by that? That means you're a very good oxidizing agent. How you will come to know? By measuring the electropotential, standard electropotential. How to measure it? By comparing with reference electrode. Which are the reference electrode? So either we call it a standard hydrogen electrode, or we can take caramel. And by arranging these electropotential, we get electrochemical series. And there's a lot of advantage. For example, all the metals which are above hydrogen can liberate hydrogen from dilute acids. The metal which is above can displace the salt which is below. The metal which is above can displace the salt which is below. And by looking at the E naught values, we can tell who is the anode and who is the cathode. Say, for example, if you're having a negative E naught value, say there is a potassium, minus 2.9 volts. Then you are having a copper with plus 3.4. And whom you will take it as anode? Very simple. Anode is the where the oxidation takes place. Means it should be a lose electron. Means you should give electron. Who will give electron? I told you, one which is having minus value. He can become anode. And then if this fellow can become a cathode. All these things we can make out just by looking at the electrochemical series. Then, what is the relation between this particular E and the concentration of reactant and product? We call it as an Nernst equation. E of SL is equal to E naught minus RT by NF log N Q, where Q is a reaction quotient. What is the reaction quotient? Nothing but product and reactant. And this we can modify a little bit. At 25 degrees Celsius means it is standard temperature. The value 2.303 RT by NF. Okay, we can take it as what? 0.0591. Why is it 2.303? This is in log to base 10. No, here what we have done? Here we have taken log to base 10. When you take to log to base 10, you know that one. We have to multiply by 2.303. And 2.303 RT by F at 25 is 0.059. So we can replace that entire thing in these equations. So these three equations, remember it. These are all Nernst equations. One, at when I convert into log 10. And this is at 25 degrees Celsius. This is at 20. Please remember it. Very, very important. Then this equation also, please remember it. So what is this equation? To find the E of a concentration cell, E of SL is equal to what? 0.059 by N. N is the number of electron lost in the annihilation. Log of C2 by C1, that is the concentration. That can also be written as E naught of SL is equal to 0.059 log of Kc. And the relation between the E of SL and delta G is equal to minus NF E of SL. And always remember, delta G is negative for spontaneous reaction. And delta G is equal to 0 at what? Equilibrium. And this can also be written as what? Delta G naught is equal to minus 2.03 all RT log Kc. This equation also, please remember it. Faraday's first law, you know that one. When electric current is passed through a electrolyte, The mass of the substance deposited depends on what? So the charge which is passing through it. That means W is equal proportional to Q. Or we can write W is equal to Z into Q. Z is the electrochemical equivalent. And we know that Q is nothing but IT. So we can write it as Z80. Remember this one. If Q is equal to 1, then W is equal to Z. That means 1 Faraday charge deposits 1 gram equivalent weight of any substance. That means 1 Faraday is equal to 1 mole of electron. 1 mole of electron, obviously. Then what is the second Faraday's law, sir? When equal electricity is passed through 2 or more cells, then the amount of substance deposited is directly proportional to equivalent mass. That is, W1 by W2 is equal to E1 by E2. These are numbers. Then you know that if you come to conductivity, conductivity is nothing but reciprocal of resistance. You know that resistance is equal to what? Sir, ohms, sir, common unit is ohm. SI unit is, remember this one, mho. And what is conductance? Conductance is reciprocal of resistance, is equal by R. So what is kappa, sir? Conductivity or specific conductivity? Kappa is equal to G into L by A. What is G? Conductivity. 1 by R, L by A we can write. Or we can write it as 1 by rho. That is the inverse of specific resistance. The unit is Simon per meter. So what is equivalent conductivity? Conductivity due to 1 gram equivalent weight of a substance. What is the formula? Sir, equivalent conductivity equal to 1000 into kappa by normality. What is molar conductivity? Conductivity to 1 mole of a substance. 1000 into kappa by molarity. What is cell constant? Is equal to L by A. Remember this one. Okay, calculate L by A. Per meter is the unit. So already I told you what is molar conductivity, what is specific conductivity. I told you already. Please remember these equations. So Debye-Akal-Wonsager equation. Please remember this one. So what is this one? Molar conductance at a given concentration is equal to molar conductance at infinite dilution minus B into square root of C. So what is this B or C? This C is the concentration, B is the constant value, which depends on the electrolyte. Next one. So what is Kolras says? At infinite dilution, molar conductance of an electrolyte, remember this one, at infinite molar conductance of an electrolyte depends on what, sir? It depends on sum of what? Number of ions present per formula unit. For example, the molar conductance at infinite dilution is given by sum of Na plus and Cl minus. Then coming to these types of cell, we know that primary cell and secondary cell. So what is this primary battery? For example, dry cell, what we use in our home, we call it as electrolytic cell. We use it in batteries, transistor, clocks, and everything. Where anode is a zinc container and cathode is a graphite rod with MnO2 and a carbon black. So what is happening at anode? Oxidation, you're giving electron and cathode is accepting electron. So there's a flow of electron and current is generated. How much? 1.25 volts hour. The other example is mercury cell. This is usually used in watches and calculators. So which is the anode? Zinc amalgam. What is the cathode? Paste of mercury oxide and carbon. So what is the electrolyte? Paste of KOH and zinc oxide. So what is happening at anode? So there is a loss of electron and gain of electron in cathode. So there's a movement of electrons. We call it as a current is generated. Electricity is generated. How much? 1.35 volts. Then another example of this particular secondary battery. You know that primary battery cannot be reusable. Secondary battery can be reusable. What is the anode? So spongy light. What is cathode? So lead packed with lead oxides. What is electrolyte? 38% by mass of sulfuric acid. So what is happening at anode? You are losing the electron. PbSO4 becomes PbSO4. And at cathode, PbO2 accepts electron to become PbSO4. So how much? What is happening here? So current is generated, electricity is generated. And this can be reversed. This reaction can be reversed by charging it again, and it can be used again and again. So fuel cells. What is fuel cells? We know about hydrogen oxygen fuel cells. These are the fuel cells where chemical energy of a fuel directly converted into electrical energy. What is that? Here anode is a porous carbon electrode and cathode is a porous carbon electrode where you are having electrolyte NaOH and KOH. So what is happening? Again, the H2 combines with OH to form H2O plus and the electrons are generated. And the O2 accepts these electrons to form what? 4OH minus M. And this cell continuously runs as long as H2 and O2 are supplied. Coming to the first question. So which of the following electrolytic solution has the least specific conductance? Which will have a least specific conductance? So how to tell this one? What is specific conductance? Kappa. This inversely proportional to what? Concentration. More the concentration, so lesser the specific conductance. Least is the value. But if more dilution is there, that means the value will increase. The value will increase. So let us not take the diluted value. What is the diluted value? 0.02, 0.2, all these things we should not take. More concentrated value, which is more concentrated to normal, sir. There it will be least value. Least value. So we have to take 2 normal. 2 normal means, sir, option A. Option A we will take. What is the option? Let us check it out. Yes, sir. First option is the answer. The standard electropotential for the reaction R the standard electropotential for the off-cell reactions are so a cell is constructed by using 2 electrodes. Which are the 2 electrodes? So zinc and the iron. So what is asking? He's asking EMF of the reaction is reaction. So we have to find out first who is the cathode, who is the anode. Who is the cathode, who is the anode? I told you, anode is the one where the oxidation takes place. Where oxidation takes this. You lose electron. You lose electron. You give electron. You give electron. So who is giving electrons? So zinc is giving electron. Zinc is giving electron by giving 2 electrons. So zinc is the anode. So then who is the cathode? Sir, copper is the cathode. So what we can write? We know that how to calculate E naught of a cell. E naught of a cell is equal to what? Sir, E naught of a cathode minus E naught of an. So what is the cathode value? Already is given. Which cathode? Copper. Copper value, sorry, what is given? Iron. Here is given iron. So what is the iron value? Is given. How much is given? Iron has gained electron to give 0.44. We'll write 0.44, sir. Minus 0.44. Minus of anode is how much? Minus 0.76. So how much it is? So it comes to around 0.32 volts. 0.32 volts means the option is, what is the option? It's a plus, no? Plus 0.32. So option is not D, option is C, sir. Option C. Next one. So in the electrolysis of acidulated water, it is desired to obtain 1.12 cc of hydrogen per second under STP condition. Under STP condition. The current to be passed is, how much it is? How much it will be? So how to do this one? He only says at STP. And we know that at STP, 1 mole of hydrogen. So what is 1 mole of hydrogen? That is 2 grams. Will always gives you 22,400 cm cube. cc of space it will occupy. It will occupy. But yes, again, how much? 1.12 he says. 1.12 cc. Then number of equivalents of hydrogen is how much? We don't know. Number of equivalents of hydrogen is how much? We don't know. How to calculate? That can be calculated class multiplication. How much? So 2 grams of hydrogen into 1.12 divided by 22,400. How much it comes? So it comes out to be 10 to the power of minus 4. That means that much amount of Faraday is required. So number of equivalents of hydrogen is 10 to the power of minus 4. That is, number of Faraday required is that much only. Faraday required is 10 to the power of minus 4. What is 1 Faraday? 1 Faraday is 96,500 coulombs. Then 10 to the power of minus 4 into 96,500 coulombs. So how much it is? 9.65. That is the amount of current, sir. 9.65 means, sir, option A it is. Option A, sir. What is the next one? The one which decreases with dilution is one which decreases with dilution is. What is the option there? So it will be specific conductance. (9.65C) of electric current is passed through fused anhydrous magnesium chloride. The magnesium metal thus obtained is completely converted into Grignard reagent. The number of moles of Grignard reagent obtained is, how much it will be? We have to calculate number of moles of Grignard reagent. He is saying 9.65 coulombs of electric current is passed through fused anhydrous magnesium chloride. That means when electric current is passed through one electrolyte, it is nothing but Faraday's first law. Say Faraday's first law. That is, we know that W is equal to what? Proportional to Q, sir. Or we can write it is equal to W is equal to Z into Q. And we know that Q is equal to what? IT. So we can write it as Z IT, sir. Z IT. But Z is equal to what? Sir, Z is equal to equivalent weight by Faraday, that is 96,500 coulombs. Then we can write W is equal to, so equivalent weight of magnesium 12 by 96,500 into I. He says 9.65 cc of current is passed through it. That means IT value is 9.65. So how much we get from this one? So we can cancel this 965. We get what? 12 into 10 to the power of minus 4. Minus 4, we get it. We know that 24 gram of magnesium, if you take that, is equal to 1 mole. That is equal to 1 mole of Mg2. Then how much we got? We got how many grams? We got 12 into 10 to the power of minus 4. We got it. Hagadre, how much it is? X. X is equal to what? So X is equal to 1 into 12 into 10 to the power of minus 4. Minus 4 divided by 24. 24. How much it will be? So we can write it as 5 into 10 to the power of minus 5. That means our option is C is the option.
Your audio is off, sir.
Oh, sorry, my audio is done. Okay.
Okay.
Now, how to do this one? Is given equilibrium constant. And he has given standard EMF of the galvanic cell involving 3 moles of electron. Its redox reaction is 0.59. We know that E naught of a cell is equal to 2.303 RT by NF. And how to associate with equilibrium? Sir, lucky. And this entire thing, I told you, 2.303 by FRT at 25 degrees Celsius. What will happen? Sir, at 25 degrees Celsius, it becomes 0.0591. We can write it as 9 n log k. Okay. So we know E naught now. What is E naught? We know. So E naught is equal to 0. He has given 59. And N also he has only told 3 moles of electron, you lost it. We can just substitute it. Then it becomes what? Sir, log k is equal to E naught into N by 0.0591. What is E naught? Sir, 0.59 into 3 by 0.0591. And if you simplify it, how much it will be? Sir, 29.9. 9.9. That is log k. That is log k. What we have to do? We have to find out k. What is k? K is equal to, we have to take it as anti-log. Sir, anti-log of 29.9. That means it is almost comes equal to 10 to the power of 10, sir. Ten to the power of 30, that is 30, no? 10 to the power of 30. So 10 to the power of 30 means what is the option? Sir, option is D. Option is D. Next one. The standard EMF of a galvanic cell in the same way as given 2 moles of electron, its redox reaction is 0.49. The equilibrium constant for the redox reaction of the cell is. And if you observe, what is the difference? In a last problem, they are given 3 moles, and in this problem, they are given 2 moles. What we have done in our last problem? We have done log k is equal to, what we have done? E naught into N by 0.059 we have done. What is E naught? He has given 0.5. Look at this. Both appeared in the same examination in a different year. Instead of 3 moles, you just write 2. And this is 0.059. 0.59. How much we get? This is 20, sir. That is log k is equal to 20. I told you. Then what you do? Shift the log towards other side. That becomes anti-log. Anti-log of 20 is nothing but 10 to the power of 20. So what is the option? 10 to the power of 20 means, sir, in this case, option is A. So the approximate time duration in hours to into electroplate 30 grams of calcium from molten calcium chloride using the current of 5 amperes. That means you are passing a current through one electrolyte. When you're passing a current through one electrolyte, that means it's a Faraday's first law. So it is a Faraday's first law. What is that? So W is equal to Z into I into T. Z into I. What you have to calculate? You have to calculate time here, approximate time duration in hours. You have to calculate. That we don't know. Then how to do it, sir? We know that W is equal to, what is that? So Z is nothing but what? Equivalent weight by Faraday. That is I into T. So what is Faraday? Equivalent weight is how much? Equivalent of calcium is 20. Or we can take it as 40 by 2. Why is it 40 by 2? Because molecular weight, atomic weight of calcium is given 40. So the equivalent weight will be, sir, 20. So what is the value? So 20, equivalent weight is 20. By Faraday is 96,500. So what is the I? You are only telling 5 amperes. Time, I don't know. I don't know. What is the mass? Weight is what? 40. You are given 30 grams. Sorry, 30 grams you have taken 30. So time we have to calculate. So how much? If you calculate time, then time is equal to, sir, it becomes 28950 seconds. To convert into hours, what I have to do? Just divide it by 360. 60 minutes, 60 seconds. So T is equal to, so 28950 divided by 3600. It comes to around 8 hours. 8 hours means, sir, option is A. Is A. Next one. The equilibrium constant for the reaction. E naught of SLE is given. What we have to find out? We have to find out K. And we know E naught and K, how they are related. Again, this is the same question what you have done last time. The relation between E naught and K. What is the relation between E naught and K? So E naught of SL is equal to 0.0591 by N log of K. Okay. Same way to practice it. The option is yes, sir. Then, which one of the following has a potential more than 0? He's asking. Which are they having a potential more than 0? What is given? Is given a concentration of H plus. H plus. So we know that E of SL is equal to minus 0.591 into log of P of H2 divided by H plus. H plus means concentration of HCl. concentration of HCl. So this H plus value we have to keep on substituting. In the first option A, the concentration of H plus is equal to 1. So the E of SL becomes how much? So it's 0. 0. Whereas in case of B, the concentration of H plus is not 1. Concentration of H plus is, he says, 2. So E of SL will be more, sir. Why? This becomes 0.591 into 0.03010. That is almost 0.177. 177. This is minus. So option would be B, sir. Next one. So the EMF of a galvanic cell constituted with electrode, zinc and iron is. Already this we have done it. This we have done it before. We have calculated E naught. What is E naught of a cell? So E of cathode minus E naught of anode. So who is anode, who is cathode? Both are having a negative value, minus 0.6. One is minus 0.4. Very simple. If both are having negative, one who is near to 0 will be cathode, and one who is away from 0 will be anode. One who is having more negative value is anode. That means E is the reducing agent. That means E undergo oxidation. That means E gives electron. Gives electron. So we know that now. So cathode is iron. How much it is? Minus 0.41 minus of minus 0.76. 76. How much it will be? So it will be plus 0.35. 25. So option would be C, sir. So for hydrogen oxygen fuel cells at 1 atmosphere and 298 Kelvin, delta G naught is given, and is asking for E naught. And we know that the relation between E naught and delta G naught is given by the equation. So delta G naught is equal to minus NF E naught. NF E naught. Delta G naught is given. Sir, it's a 240 kilojoules. That means 24,000 joules. Minus N. Here, how many electrons are consumed here? 2, sir. Into Faraday means 96,500 into E naught, sir. So we have to calculate E naught. Becomes E naught is equal to what? So it's a 1.24 volts. That is option B, sir. How many coulombs of electricity are required for the oxidation of 1 mole of water? Just now we have discussed now. 1 mole of water requires 2 electrons. It gives you 2 moles of electron. Say 1 mole of 1 mole of water. Gives you how many? I told you N is equal to 2. N is equal to means it is equal to what? 2 Faraday. 2 Faraday means what? 2 into 96,500. How much it is? So that is nothing but 19300 coulombs. Or you can write it like this. 1.93. If you write it as 1.93, we can write 10 to the power of 5 coulombs. We can write it like this also. What is the option? So the option is nothing but D. While charging the lead storage battery, you know that it's a secondary cells which can be rechargeable. While charging the lead storage battery, so what is happening is asking, and reaction occurring during recharging. That is a question. What may be the option? So during recharging, PbSO4, so lead sulfate will give back what? It will give back sir Pb and PbO2. Plus what you get? You get sulfuric acid. By what? From water, we get sulfuric acid. So what may be the option? So the option is PbSO4 is being converted into or reduced to Pb. That is option C. In hydrogen oxygen fuel cells, the cell reaction occurring at cathode is asking at cathode, what is the reaction taking place? I already told you, anode means you should give electron, oxidation should take place. Give electron. How this happens? I told you, their hydrogen combines with what? OH minus ion to give you water. Plus electron it gives. How many? 4 electron it gives. So what is cathode? Cathode should accept electron. Sir, cathode should accept electron. Accept electron. So what will happen? Who is at cathode? O2. O2 will accept 4 electrons. Accepts 4 electrons. Becomes what? So it becomes 4 OH minus ion. So what is the equation? Sir, equation is A, sir. Belongs to A. Which of the following is incorrect in galvanic cell? What is incorrect? Well, you have to try. All of you should try. Keep on trying. I can see only few response. Rishabh, Iranna, Lalit. Everybody has to respond. Give me option. Yeah, Rishabh, you're right. Lalit. Then all of you should put an answer. So what is happening here? He's asking, incorrect is asking. I already told you, anode at anode, what will happen? You give electron, whereas at cathode, you accept electron. You accept electron. So, but in the last statement, he says cathode are lost. He says electrons are lost. That is wrong, sir. So D is the option. A secondary cell is the one which I told you secondary cell can be recharged. Option C. So the amount of current in a Faraday required for the reduction of 1 mole of dichromate ion into Cr3 plus is how much it is? What you have taken dichromate? What is dichromate? Cr2O7. Okay, 2 minus give rise to what? Cr3 plus. And if you observe here, oxidation number of Cr plus 3 is plus 3. What is the charge? That is the oxidation number. In dichromate, sir, we have to calculate. How to calculate, sir? Cr2O7 minus 2. No. Whatever the charge will be taken as a total oxidation number. So chromium, we will take it as 2x, and oxygen is 7 oxygen atom. Oxidation number is 2. So 7 to is 14 it becomes. 2x minus 14 is equal to minus 2. And if you calculate x, what it becomes? Plus 6. So here, the oxidation number of chromium is plus 6. So what is the difference? So the difference is from plus 6 to plus 3. How it becomes? By accepting 3 electrons. But there are Cr2. That means you have to make it as 2. So for 2 Cr, you require 6 electrons. And 6 electron is always equal to 6 Faraday. 1 mole of electron is equal to 1 Faraday. 6 mole of electron is equal to 6 Faraday, sir. What is the option? Option C. Next one. By passing electric current, sodium chloride is converted into NaClO4 according to the equation. How many moles will be formed when 3 Faradays of charge is passed through NaClO3? The same way, just now I told you. In the similar way, you have to do it. We have NaClO3, NaClO3. Give rise to what? It gives rise to NaClO4. ClO4. So what is the oxidation number here in NaClO3? First we'll find out. Very simple. In NaClO3 means we'll write it as total oxidation number is 0. Sodium we know, plus 1. Chlorine we don't know. Oxygen is 3 into minus 2 is equal to 0. So chlorine becomes what? So chlorine becomes plus 5. We'll write it here. So the chlorine is plus 5. Is plus 5. Then we'll go for NaClO4. So NaClO4. In the same way we have to do. The total oxidation number is 0, sir. Sodium we know, plus 1. Chlorine we don't know. Oxygen, so it is a 4 into minus 2. 4 to the 8 is equal to 0. So chlorine becomes, sir, it's a plus 7. So we write it here, plus 7. So it is now plus 5 to plus 7. Then how many electrons are in here? If plus 5 has to become plus 7, that means you have to lose 2 electrons. Means 2 electron is in order. So what is the answer? He says, how much you get when you pass 3 Faraday? Means for 1 mole of NaClO3, to make 1 mole of NaClO4, you require 2 electrons. 1 mole of NaCl4 require 2 electrons. 2 electron means it requires 2 Faraday. 2 Faraday. He is asking thus, 3 Faradays are passed. How much you get? If you pass 3 Faraday, how much? So cross multiplication. X is equal to what? So 1 into 3 by 2, sir. How much it is? So 1.5 moles. 1.5 moles means what is the option? Sir, option is C. Option is C, sir. Yeah, Ramesh, very good. 1.5. Next one. In the electrolysis of aqueous sodium chloride, which of the off-cell reaction will occur at anode? What is aqueous sodium chloride? Aqueous sodium chloride means NaCl. When you pass electric current, what do you get? Na plus and Cl minus. And Cl minus will go towards anode. What they happen in anode? I told you, they lose electron. Each chlorine lose electron. Lose electron. Becomes what? Cl plus electron. So 2 Cl minus. They give Cl minus gives you off Cl plus electron. Where this reaction takes place, the option A, sir. A is the reaction which takes place at anode. So the charge required for the reduction of 1 mole for permanganate into MnO2. In the same way, what we have done, I told you, just find out the oxidation number. What is the oxidation number of MnO4 minus? And it has become what? MnO2. In MnO2, what is the oxidation number of manganese? Oxygen is, sir, minus 2. That is minus 2 into 2. 2 to the 4. That means it becomes plus 4, sir. Here, oxygen is, sir, minus 2. 4 to the 8. 8 minus 1 means it becomes, sir, plus 7. So plus 7 to plus 4. How it becomes plus 7 to plus 4? That means you have accepted 3 electrons. 3 electrons. I told you, 3 electron means it is equal to 3 Faraday. So 3 Faraday means what is the option? Sir, option is B. Sir. Option is B. At a particular temperature, ratio of molar conductance to specific conductance. So what is molar conductance? I told you molar conductance is equal to kappa into 1000 by what? Concentration. What is concentration? Molarity. Molarity means the symbol is capital M. What it says? Ratio of molar conductance to specific conductance. What is specific conductance? Kappa. So molar conductance divided by kappa, it becomes what? So 1000 by molarity. 1000 by molarity. This is the equation. And what is the equation is given? Kappa is equal to 1000 by molarity is how much? So molarity is 0.01. So if you take it upper to numerator, it becomes what? 10 to the power of 5. What is this one? 10 to the power of 5. cm cube per mole. That means our option is. Okay. Last year question we will take up. So 2021. 2022. So what is the specific conductance of 0.1 molar nitric acid is 6.3 into 10 to the power of minus 2 per ohm per centimeter. What is the molar conductance? Just now I told you. No? Molar conductance is equal to what? Kappa into 1000 divided by molarity. Yes, given that value kappa, how much? 6.3 into 10 to the power of minus 2 into 1000 divided by the molarity is 0.1. So how much it becomes? So it becomes 630. 630 means, so it is option C. Next one. So for spontaneity of a cell, which is correct, sir? I told you, when delta G is negative, the reaction is spontaneous. So reaction is spontaneous. When delta G is negative, sir, E becomes positive. E becomes positive. So what may be the options? So B is the answer. So in a fuel cells, dash is used as a catalyst. We know that platinum palladium is used as a catalyst. Sir, molar conductivity is maximum for the solution of which one? Molar conductivity is inversely proportional to concentration. Sir, molar conductivity is inversely proportional to concentration. Lesser the concentration, more the molar conductivity. That is, V is lesser 0.01 molar. Sir, option B, sir. B. We will discuss a little bit about electro P block elements also. So in P block element, we are having group 15, 16, 17, and 18. We will have a brief look at that one. If you take a group 16 in the oxygen family, and group 15 is a nitrogen family. It is. Okay. Very, very important here. The oxygen state is, it can vary from -2 to +2 in oxygen, whereas in others, it is up to +6. Remember this one. And general trends. Atomic size is increasing. density increases, ionic radius increases, boiling and melting point increases, metallic character increases. So decreasing down the group, ionization energy, electronegativity, electroaffinity, that decreases, sir. Melting point, boiling point also decreases from tellurium to polonium, bit, remember this part. Thermostability of what is that? S to E, okay, is also more. So what is the exception here? O shows tendency of P-pi bonding, where other forms D-pi bonding. So electron affinity of oxygen is less than electron affinity of sulfur. And sulfur shows catenation property. Why oxygen is different? Because it has a small size, high electronegativity, and non-availability of d orbitals. So how it differs? For example, oxygen is a diatomic, whereas all others are solid. It has only oxygen state of +2 only, whereas the others it is up to +6. Oxygen is highly non-metallic due to high electronegativity. So these are the few differences due to anomalous property. Next one. Little bit we have to understand about oxo acids. Okay. For example, H2SO3. Remember the shape of it. They act as a reducing agent. Remember this one. As well as oxidizing agent. The sulfuric acid, that is H2SO4, is also called the oil of vitriol. S is equal to what? +6, sir. And remember, this is also dibasic. Means what? It can give 2H plus. Highly corrosive. So peroxide monosulfuric acid is also called as scarose acid. H2SO4, SO5. And it's a powerful oxidizing agent. And it is a monobasic. So peroxide disulfuric acid, that is called as Marshall's acid, H2SO8. Remember the structure where they have a O linkage, peroxide linkage. So they're also very good oxidizing agent. Coming to group 17 elements. Which are the group 17 elements? Sir, halogen family. Configuration is NS25. Fluorine is having only -1, whereas chlorine can range from -1 to +7 in all these things. What are oxo acids? The oxo acids of this particular halogen family. Hypohalous acid means HX4. Oxygen state is +1 like HOF, HOCF, HOBr, HOI. When you have oxygen state of +3, you get HXO2. Only chlorine forms it. Alic acid, HXO3. Next one. Sir, peralic acid. Their oxygen state is +7. The thermostability, acidic strength decreases when you go towards the oxo acids of iodine. And the oxidizing nature increases. Coming to group 18, that is noble gas. Especially you should remember the structure of this noble gas. First one is XeF2. It's a linear and sp3 aberration. It can act as a chlorinating agent. Remember this one. Then we're having xenon tetrafluoride. What shape? Square planar sp3d2. It's a colorless crystalline solid. Remember this one. It can undergo disproportion, both oxidation reduction. It's a fluorinating agent. So xenon trioxide, what shape it is having? Pyramidal shape. Remember this reaction. On complete hydrolysis gives xenon and xenon trioxide. When it reacts with water, it gives xenon trioxide. They undergo disproportionate when dissolved in alkali. What are the next compounds are in xenon? XeO2, XeOF2, xenon oxidifluoride. What is the shape? Sir, T shape. What is the abbreviation? sp3d. When they undergo hydrolysis, they form XeOF2. XeO2F2, xenon dioxidifluoride. What is this? So it's a distorted trigonal bipyramidal shape, sp3 aberration. Sir, on hydrolysis, it can give XeO2F2. XeF6 on hydrolysis gives XeO2F2. XeOF4 on treating with silicon dioxide gives XeO2F2. And it can undergo hydrolysis readily to form XeO3. And remember, XeF6 cannot be stored in a glass vessel. They can react with glass, it forms explosives. Let us take some question in this one. Excess of PCl5 reacts with sulfuric acid gives what? What it gives? He says excess of PCl5. So sulfuric acid, when they react with PCl5, the common compound is what? The H reacts with Cl to form HCl. So 1 chlorine is gone. 4 chlorine is there. In that, 3 chlorine atom is taken by PO to form phosphorus oxychloride. So only 1 chlorine is left behind. What will happen? It becomes a sulfuric chloride. So what is the option then? A, we get sulfuric. So which is most easily liquefiable rare gas? Easily liquefiable. So what may be the option? They are very difficult. Difficult to liquefy. Why? Not easy to liquefy, sir. Because they have a very weak force of attraction. So even if you put a pressure, they will not liquefy. But it can increase from xenon. Why, sir? Slowly, the force of attraction increases. So force of attraction increases. So xenon means, sir, option C. So in the brown ring test, the brown color of the ring is due to what? What we get? So what we get in a brown ring test? What we do, brown ring test, we do it for what? So we do it for test for nitrogen. So what we'll do, we add ferrous sulfate. And this becomes what? This becomes ferrous sulfate, nitric oxides, or nitrosoferrous sulfate. We got nitrosoferrous sulfate. What is this nitrosoferrous sulfate? So option B. So helium is used in balloons in place of hydrogen because what may be the reason? We can use hydrogen also. Both are lighter in nature, but hydrogen catches fire. So hydrogen catch fire easily. So nowadays they use helium. So what will be the options? Sir, option C, sir. In which of the following ammonia is not used? Ammonia is not used. So what is a tolerance reagent? So it is ammoniacal nitrate. So it's ammoniacal silver nitrate. Ammoniacal silver nitrate. So the D cannot be. So whereas B and C, we use what? The group reagent, ammonium hydroxide and ammonium chloride. So they are also not the option. What is the option? Sir, option A then. Why, sir? It is used to detect ammonium radical. What it is the solution of potassium, mercurate, iodide. Argon is used in what? So we use it in what? Welding, that is high temperature welding, we use it. So option is B. Molecules of noble gas do not possess vibration energy. Why they don't have a vibration energy? Sir, they have a vibration energy when they have other atoms, but these particular noble gases are, sir, monatomic. Monatomic. What is monatomic, sir? Option is, sir. The number of naturally occurring p block elements that are diamagnetic is, that are diamagnetic. What may be the option? Naturally occurring. Naturally occurring means, sir, only 5, sir. Why? They all belong to group 18. Group 18. Why? They have a NP6 configuration, means completely filled. Completely filled means there is no unpaired electron. So no unpaired electron. When there is no unpaired electron, that means they are diamagnetic. So in options are option C. Is not required. Next, which of the following is employed in a flash tubes in photography? Which of the following is employed in a flash tubes in photography? So mainly they use krypton and xenon. Krypton and xenon. So here the option may be anything you can take. Either you can take C or you can take D. So both may be option. Even you can take krypton also, you can take xenon also. So option can be C also, D also. So MnO2 reacts with HCl to give you what? He says, when MnO2 reacts with HCl, they form MnCl2. MnCl2. Then H combines with O to form water, and plus chlorine also becomes liberated. Then he says the gas, which is the gas here? The chlorine. That is A. The chlorine will react with fluorine. Yes, sir. When they react, they form ClF3. So ClF3 is the B. That is also gas. Then this ClF3 combines with U. What will happen? Sir, it becomes UF6. UF6. What is UF6? Sir, C. What is remaining then? So then ClF is remaining. What is ClF? Is so what is this? A, B, C, D. A is a chlorine, sir. That means option B. Option B is the answer. Next one. The species that is not hydrolyzed in water is will not hydrolyzed in water. What will be the option? And if not hydrolyzed, why? Sir, answer is P4O10 because when you add water, sir, it will again become orthophosphoric acid. Orthophosphoric acid means what will be the option? Sir, option is B. Sir. The statement that is not correct is what is the statement that is not correct? What may be the option? Hypophosphorus acid reduces silver nitrate to silver. Yes, sir. It is right only. PCl5 can exist as PCl4 plus and PCl6 minus. Yes. Then let us go to C. Pure phosphine is non-inflammable. Yes. Then what is D? E says phosphorus acid. What is phosphorus acid? H3PO3. PO3. Then if you eat it, so what we get? Sir, we get H3PO3 become HPPO4. Plus, of course, we get PH3. H3PO4 is what? There's a orthophosphoric acid. Orthophosphoric acid. What is orthophosphoric acid? Sir, option is D, sir. D is the answer. E says metaphosphoric acid. That is the wrong thing. A crystalline solid X reacts with direct HCl to liberate gas Y, says gas, which decreases acidified KMNO4. Acidified KMNO4. That means it has to be SO2. The gas has to be SO2. SO2 means what may be the option? So it has to be Na2SO3. Na2SO3. What will happen? So Na2SO3 reacts with HCl to form NaCl plus SCO2, SO2 plus H2. That's what it says. Why? Why decreases Kyono? When you pass Z gas, what is Z gas? Is slowly passed into aqueous solution of Y. What is aqueous solution? SO2 plus H2O becomes what? So it becomes H2SO3. And then he says H2SO3 reacts with the gas Z. What is Z? The colloidal sulfur is formed, he says. Sulfur is formed. Then Z should be H2S. H2S. So what may be the option? Let's see, check it out. So first he says a crystalline solid X. X should be Na2SO3. Then Z, it should be H2S. Then option C, sir. The aqueous solution of following salt will have the lowest pH. Which will have a lowest pH. What will be the option? Lowest pH means it should be more acidic. So lowest pH means it should be more acidic. Or acidic. Let us try one by one. So NaClO. NaClO, he says aqueous. Aqueous means what? It has to be H2O. What will happen? So we get NaOH plus HClO. HClO. So NaOH is a base. That means the pH will increase. pH will increase. What is asking? Lowest pH. So A cannot be. Let's take B. What is B? Sorry, NaClO4. We call it as a sodium chloride. This reacts with water and to form, again it becomes NaOH. Plus what you get? SClO4. SClO4. And SClO4 is a strong acid. When it is strong acid, pH will decrease. So then the option B is right, sir. B is right. Which of the following compound of xenon has a pyramidal geometry? What may be the option? If you take xenon, xenon is having a one unpaired electron. Unpaired electron. And it is attached to O3 means 3 oxygen through what? Double bond. So this can have a pyramidal structure. That is, what is molecule? Sir, XeO3 can have a pyramidal structure. That is option B, sir. Sulfur salt contains. What will be the option? Sulfur salt means it's a colloid. Colloid means what? You'll be having aggregates. Aggregates of what? Sulfur. Sir, option C, sir. Next one. The property which is not true about fluorine is. What is not true about fluorine? So most reactions are exothermic. Yes, sir. A is right. It forms only one acid. Yes. It has highest electronegativity. Yes, sir. Then what is the option? So what is D, sir, there? E says high FF bond dissociation enthalpy. Wrong, sir, because fluorine is very small. When there is very small, there's a lot of repulsion. When repulsion is there, just low energy is enough. What may be the option? That means the dissociation enthalpy is not very high. That is not true, sir. That is the option. That is the option. Which is true regarding nitrogen? What is true regarding nitrogen? Nitrogen is electronegative. E says less. Nitrogen is electronegative. Because electronegativity, when you go from left to right, increases. So tell me, what is the answer? So what may be the option? Has a low ionization enthalpy, he says. No, sir, nitrogen is off-filled. Off-filled means it has a high ionization energy. High ionization energy. So that cannot be the option. D orbitals are available. No, sir. No. That is not option. So answer is, so it has to be D. The shape of XeF6 is, what will be the shape? Is an octahedral. But what kind of octahedral? It's a, we call it as a distorted octahedral, we call it as. XeF6 means you're having fluorine. How many? 6 atoms. It has to be distorted octahedral, so that means B is the option. Extraction of a chlorine from a brain solution is based on what? Based on what? What is a brine? Brine is nothing but NaCl. And when electronic current is passed through it, we get Na plus and Cl minus, I told you. Cl minus will go towards anode. What will happen there? So they lose electron. They lose electron to become what? Of Cl, I told you. Plus electron. That is nothing but oxidation. Losing electron is nothing but oxidation, sir. Option is C. We'll take few last year paper. We'll take. Which of the following compound on heating gives N2O? Which of the following compounds on heating gives N2O? Nitrous oxide, we call it as. Let us take lead nitrate. So PbNO3 twice. So this gives you what? PbO plus NO2. This is nitrogen dioxide, sir. So this cannot be the answer. So A cannot be the answer. Let us take B. What is B? Sir, ammonium nitrate, NH4, NO3. Yes, sir. This upon heating gives you N2O plus water. So option is B, sir. So which of the following property is true for the given sequence? Is true for the given sequence. A, he says reducing properties. Okay, NH3 is more. So this is wrong. Thermostability, yes, sir, may be right. Bond angle, yes, may be right. D, acidic character, so that's wrong. So what may be the option? Option may be both B and C. So for this, we can put both B and C. XCF6 on partial hydrolysis gives a compound X, which has a square pyramidal geometry. What may be the option? E only says hydrolysis. What is hydrolysis? Means we are adding water. This is called as breaking a compound by using water is called as hydrolysis. So what do we get? So we get HCOF4 plus we get 2H. That is, sir, option C, sir. Next one. A colorless neutral paramagnetic oxide of nitrogen P on oxidation gives reddish brown gas Q. Q on cooling gives colorless gas R. R on reaction with P gives blue solid S. Identify P, Q, or S. He says reddish brown gas. Brown gas is nothing but, sir, NO2. NO2. That is Q, reddish brown gas. How you got it? NO2 is obtained by oxidation of NO with O2. Then this should be the P. This should be the Q. So we got Q. What is P and Q? NO and NO2. Where it is present? NO and NO2. There's only one option, sir. What is the option? C. This one, what will happen? NO2. NO2 upon oxidation, then it becomes N2O4. N2O4. This again reacts with what? Two molecules of nitric oxide to form N2O3, N2O3. So option is C, sir. The strong reducing property of hypophosphorus acid is due to what? Hypophosphorus acid is due to what? What is reducing property? It gives hydrogen. What is hypophosphorus acid? It's a PO2. What is PO2? There are two oxygen. One oxygen through double bond, another oxygen through weight. So it is having pH bond, 2 pH bond it is having. And because of this, it is reducing in nature. So option A is the answer, sir. Next, the property of halogen which is not correctly matched is. What is the property of the halogen which is not correctly matched? So let us take A. Sir, iodine is more denser than BrClF. Yes, as the atomic mass increases, density increases. This is right only. Now we will go to electron gain enthalpy. Means what? Electron affinity. What is electron affinity? It is the amount of energy liberated when electron is added. So it is all about energy liberated. It is all about energy liberated, sir. Liberated. And you know that in a group 17, as you go down first fluorine, chlorine, bromine, iodine, no? And down the group, electron affinity decreases. And then we think that fluorine is more. Fluorine more than Br more than I. This is what we think, but this is wrong. Sir, this is wrong. Why, sir? Fluorine is very small. It cannot accept electron. There's a lot of repulsion will be there. So slight changes will be there. Chlorine becomes more than F. Then everything is same. So this should be the arrangement. So B is wrong. Then when it is wrong, that is not correctly matched. This is the option. Next one. Which noble gas has the least tendency to form compound? First of all, noble gas are less reactive, but among them, who is that? Sir, helium, sir. Helium. That means C is the option. Sir, ammonium dichromate on heating liberates a gas. The same gas will be obtained by what? What may be the option? What gas it liberates? Ammonium dichromate. First, let us understand that one. What is the dichromate? Sir, NH4 twice. Cr2 O70s. He says on 18. Gives a gas, he says. What is gas you get? First of all, we get Cr2O3, sir. Plus water we get. So what is remaining then? So the nitrogen is remaining that comes out as a nitrogen gas. So we have to find out where we get nitrogen gas. Where we get it? One by one, we'll check it out. So option A, what we get? E only says H2O2 and NNO2. When they react, Na forms a NNO3 plus H2O. So option A cannot be. Let us understand B. What is that he has given? Magnesium nitrate, he says. Sir, magnesium nitrate becomes a magnesium hydroxide. Magnesium hydroxide plus it becomes, sir, N becomes ammonia. So B cannot be. Then what is C, sir? Ammonium nitrate. Sir, ammonium nitrate gives you nitrous oxide. N2O plus H2O. So C cannot be. So what is remaining? D. D has to be the answer. So what it gives, sir? It gives you N2 plus H2O. N2 plus H2O.
Sir, time is for break.
Okay. Thank you, Bagli sir.
Thank you so
Dear
much, sir.
students, in my next sessions, we'll be discussing a little bit about chemical kinetics and also first PUC revision. We'll do it. First PUC revision, we'll do it in my next session. And I will get 2 sessions. In my last sessions, we'll do mock exam.
Mock exam, whatever you are planning, please intimate to Hemant sir, sir. Accordingly, creative is made.
Yeah, we'll discuss it. Just we'll discuss this exam on day one.
Okay.
Okay, sir.
Thank you, students. Students, you can go on break for 15 minutes. You can be back sharp by 6:05. 6:05 is going to be biology, Pawan sir's class. I request you to be here.
Bagli sir.
Yes, sir.
This is let it be very clear. Mock exam means we are not doing it. We will discuss it.
That's what it was told. What I'll do is, out of this session, we will speak on tomorrow.
Okay, right.
Thank you, students. You can go on break.
Welcome to the School of Engineering at Dayanand Sagar University, main campus, Harohaldi, Kanakpura Road, Bangalore. A place that values research, innovation, and creativity. Our industry-aligned curriculum offers a blend of theoretical knowledge, practical experience, academic projects, and internships for a rewarding career in engineering. With an interdisciplinary approach, you can explore your interests by selecting open electives. The on-campus innovation labs, led by professors of practice, provide immersive learning and expertise to find the best solutions to real industry problems and give a different dimension to the students' mini and major academic projects. Our Center for Entrepreneurship supports startup opportunities and provides a perfect platform to launch your next big idea into successful ventures. We also prepare you for advanced studies in the latest futuristic technologies. Our BTech programs offer the perfect combination of academic rigor and functional experience in this ever-evolving technological landscape of the future. Experience a whole new world of academic excellence in a global environment. Dayanand Sagar University. Live the dream. Within the beautiful and peaceful setting of Dayanand Sagar University's Harohaldi campus is the prestigious College of Nursing, where you embark on a transformative journey as we flawlessly fuse academic expertise with practical skills through our advanced curriculum. Renowned for our focus on innovation and advancement, our experienced faculty members are at the forefront of the nursing field, constantly incorporating the latest advancements in technology and research into the curriculum. Our pioneering facilities, including simulation labs and clinical training rooms, provide an immersive real-world healthcare environment. The Harohaldi campus is a modern and supportive community, complete with all necessary amenities, and provides the perfect, serene environment for students to focus on their studies and achieve their goals. Join our vibrant community and prepare for a successful career in nursing. At Dayanand Sagar University's Harohaldi campus, the College of Physiotherapy is dedicated to providing students with a top-notch education in the field. Curriculum is designed to give students a comprehensive understanding of the human body and its functions, along with experiential training in the latest physiotherapy techniques. What sets our department apart is our ultra-modern facilities, including sophisticated classrooms and clinical training rooms. Our students have access to the latest technology and equipment, allowing them to hone their skills and knowledge to the highest degree. The faculty at the College of Physiotherapy is comprised of experienced professionals who are dedicated to their students' success. With our modern amenities, the supportive community, Dayanand Sagar University's College of Physiotherapy is the ideal place for aspiring physiotherapists to begin their journey. Dayanand Sagar University's College of Allied Health Sciences in Harohaldi, Bangalore, we are changing the game in medical diagnostics and treatment. Our innovative program combines theoretical knowledge with hands-on clinical training at our 300-bed tertiary care hospital, soon to expand to 1,350 beds in 3 years. Our cutting-edge infrastructure includes an advanced skill lab and simulation center to prepare you for global healthcare challenges. Plus, with regular workshops and conferences, you'll stay up to date on industry trends. Our strong curriculum is aided by technological advancements, and you'll have opportunities for innovative research at our Central Research and Innovation Wing. Gain real-life experience with 1 year of industrial exposure. Experience academic excellence in a global environment at Dayanand Sagar University. Live the dream. College is often viewed as a mere institution, a labyrinth of classrooms, textbooks, and endless exams, where our future is shaped. Yet, when we step foot on campus, we realize that we are not alone on this journey. University transcends academia, transforming into a vibrant community where individuals unite. To learn from one another, to grow and to forge unforgettable bonds. It's not always about having a precise plan. It's not always about figuring out. It's not always about reaching the finish line first. It's about discovering what we are truly passionate about. The true essence of college, however, lies beyond the confines of academic pursuits. What truly makes college so special is the life that's lived within its walls. It's about seeing things from different perspectives, exploring unique possibilities, taking on new challenges, finding joy in friendship, embracing individuality, expanding our knowledge and skills, and immersing ourselves in extraordinary experiences. It's a path that teaches us about resilience, courage, and determination. A quest that allows us to pursue our goals with purpose and clarity. A quest that helps us find balance, happiness, and fulfillment. A transformation that inspires us to live with intention, curiosity, and joy. A trail that leads us to a deeper understanding of who we are and what truly matters. It's a journey of self-discovery, where every experience shapes us into the best version of ourselves. It's a college for education. Experiences shapes experience a whole new world of academic excellence in a global environment. Many places today.
Yes, students. In another 2 to 3 minutes, biology class will begin. In between, I just wanted to give an information on anyone who wish to go for BSc nursing. Now they need to write a test. In private university, if you are taking, university will be taking the test as per the guidelines. Nursing Council of India's guidelines, the test would be taken. Physics, chemistry, biology, aptitude, and English, 20 marks each. The test would be, if you're going for government nursing colleges, government will conduct the test. The latest information on entering BSc nursing is mandatory to attend test to write to get into BSc nursing. Dear students, another just 2 minutes are there. Ask your friends to join back. You are going to have a biology class as tomorrow is NEET. And this will give you the very good tips. I think from today's discussion, if you are getting 2-3 questions, it would be great. Ask your friends to join fast. Dear students, any questions you can put in question and answers. You can ask any question regarding your career, regarding Larnodaya program. Or just now I said BSc nursing. Join fast, students. Ask your all friends to join fast. I think just 1 minute is there to begin the class. You are going to have very important topic of biology. The first few revision is very important because you are not seen that from past 1 year. You might be preparing your theory, second PUC or 12th standard. You may not have touched first PUC or 11th standard unless anyone who is very seriously preparing throughout the year might have a revised first PUC. But it is very crucial, dear students, to have a refresh of 11th standard or first PUC topics. as almost 30% in CET would appear, almost 35 to 40% in NEET. The first PUC or 11th standard syllabus appears. Pawan sir, I'll hand over the session to you. Please share your...
Yes, sir. There is one question. I think you may have to, if you want, you can answer that. There is one question in the Q&A box.
I'll just check, sir. Sir, can we join BSc Agri without CET high ranking? Okay. Rachana, BSc Agri is purely through CET ranking you need to go. Definitely you can get into without high ranking, but that is called NRI seat or payment seat that you can enter. It costs approximately 3.5 lakh a year. In BSc Agriculture University, there is an option of getting into, but that would be costing 3.5 to 4 lakh per year. Or otherwise, if you are a student of farmer, daughter or son, you can have a 50% reservation. For that, what you need to do is, you might have filled the CET form. In that form, agri quota claimed, you need to mark as yes. If you are marked as yes, you will be having separate 200 marks practical exam. If you write a practical exam and CET both together, they will consider board 25%, your CET 25%, practical exam 50%. Altogether, if you are getting even 25,000 ranking in BSc Agri, you will be getting your seat BSc Agri. For any more questions, you can just WhatsApp me. I'll be available here to answer. Pawan sir, over to you.
Yeah, thanks, sir. Can you please give the option of sharing the screen?
Yeah, I will, sir. Yes, sir. You are a host.
Okay, thank you, sir. Yeah, good evening, students. Last class, this is what... yeah, Rachana, as sir told, if you have entered the option as agriculture quota, the quota will be considered for you while allotting this seat. So in the last class, we were discussing about previous year questions, and in that, this is the question that we ended with. Like we saw, which are the following type of cell junctions is not found in animal cells. And we saw animal cells, especially in case of epidermal tissues, we have got 3 types of junctions, which are the modifications of cell membranes. When adhering junction is meant for holding 2 cells together. Tight junctions is going to prevent the leakage of fluid from the connective tissue, which will be present below the epidermal tissue. And gap junction is meant for communication or exchange of molecules between 2 cells. So let us continue with rest of this chapter. So as I told you last class also, again, I'm reminding you this time also, but that this is not just about solving questions. It is about revising the first PUC syllabus. That is why I may keep explaining some other concepts related to the question, which I feel it is important for CET. So the question here is bacterial flagellum is composed of. So this question, first let us see, this is from, you can consider it as a question from a chapter called Cell, the Unit of Life. So in this chapter, you have studied majorly 2 types of cells. One is prokaryotic cell and the other one is eukaryotic cell. Flagella, which is present in bacteria. First of all, bacteria is an example for prokaryotic cells, which means they do not have true nucleus. Like any other living cell, yavde living cell tagondruno, it will be having what is called as cell membrane. Just like that, bacteria also will be having cell membrane. Along with cell membrane, bacteria will be having one more structure. And that one more structure which is present around them is the presence of a cell wall. And I hope you know the cell wall of bacteria is made up of a chemical called as peptidoglycan. I'm repeating, cell wall of bacteria is made up of a chemical. And please remember the name of the chemical. The chemical is called as, this is cell wall, and cell wall it will be made of peptidoglycan. Now, depending upon the thickness of cell wall, and also depending upon the property of its staining property, there are two types of cells. One is called as gram-positive cells, and the other one is called as gram-negative cells. You don't have to worry much about on what basis these are called. As I told you, it is basically based on the staining property. Gram-positive will be having crystal violet color, and gram-negative will be having saffron color. But the basic difference is gram-positive will be having a very thick cell wall. Gram-negative will be having thin cell wall, and it also has an lipopolysaccharide. I'm suggesting you don't worry about that also. Just remember, cell wall is made up of a chemical called as peptidoglycan. And based on the peptidoglycan, we have got two types of cell wall, that is gram-positive and gram-negative. Now, you may remember some of the other structures which are found around this, which are called as cell appendages, such as flagella. You know, flagella in case of bacteria, it is meant for locomotion. There is no structure called as cilia in bacteria. Mattonsari ಜ್ಞಾಪಿಸ್ತಾ ಇದ್ದೀನಿ, ಬ್ಯಾಕ್ಟೀರಿಯಾಗಳಲ್ಲಿ cilia ಅಂತ structure ಇರಲ್ಲ. It has only flagella, but it has some structures which are called as villi. Villi do not help in locomotion, but villi help in the process of recombination. Conjugation ಅಂತ ಒಂದು process ನಡೆಯುತ್ತೆ, ಅದಕ್ಕೋಸ್ಕರ villi ಬೇಕು. Then it has a structure called as fimbriae, and fimbriae help in attachment. Fimbriae help in attachment of the bacterial cells to any surface. They call it as cellular appendages. It will be having something called as either capsule or slime layer. Capsule or slime layer, which are both made up of a chemical called as glycocalyx. Both of these are made up of glycocalyx. Difference is, capsule it will be having thick coating of glycocalyx, whereas slime layer it will be having thin coating of glycocalyx. Capsule helps in escaping from immune cells, whereas slime layers helps the bacteria from undergoing desiccation. ಈ ತರ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಗಳಲ್ಲಿ ಫ್ಲಾಜಿಲ್ಲಾ ಏನಿದೆಯೋ, flagella will be having a structure. ನಾನು ಇವಾಗ ಏನು yellow color ಬರೀತಾ ಇದೀನೋ, this yellow color structure that I am writing here, this structure is called as basal body, sometimes also referred as motor. To this basal body, what will be attached is a hook. This basal body will be attached with a structure called as hook. And to this hook, what will be attached is a protein structure, which is called as filament. And the protein which is present in this filament is called as flagellin. So this is called as filament. So this whole structure, which comprises of basal body, hook, and filament, all of them together forms flagella. So flagellum will be having filament, hook, and basal body. So the answer should be A. Now, again, let us try to understand a little more about other structures of this bacteria. As I told you already, bacteria is prokaryotic organism, which means it do not have nucleus, but it will be having DNA, and that DNA, it will be freely suspended like this. It is not surrounded by any nuclear membrane. And the DNA which is present in this will be double-stranded helical structure, DS. I have written it as DS, which means double-stranded helical structure. And you can see in some places, idanna neeve helbeku. You should tell me what is this structure called as. In some places, you can see cell membrane, it will be folded like this. Cell membrane, it will be folded like this. What do you call this structure as? And what is its function? Meanwhile, I'll just continue with other structures as well. With bitre ಇನ್ನೇನ್ structure ಇರುತ್ತೆ ಬ್ಯಾಕ್ಟೀರಿಯಾಗಳಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರೆ, it will be having ribosomes which are scattered, and you'll find a type of structures which is called as polysomes. What do you mean by polysomes is? What do you mean by polysomes is when many ribosomes are attached to an mRNA. For a single mRNA, when many ribosomes are attached, they are called as polysomes. Please remember that polysomes are not found in eukaryotic cells. They are found only in case of prokaryotic cells. So polysomes irutte with one mRNA and many ribosomes attached to this. And it may have some cell inclusions like many food materials which are stored. I'm not getting answer. What do you call this white color modified cell membrane which will be folded like this? What do you call this as?
Sir, Afridi Makandar, you can just put your question in Q&A box. If you raise hand, you will not be able to talk. You can put your any doubt is there, you can put in Q&A box. Thank you, sir.
Yeah. So again, I'm waiting for the answer. What do you call that white color folded structures of cell membrane as? No idea? Very good. So those folded structures, what you are seeing here, they are called as mesosomes. And mesosomes helps in performing many metabolic activities such as respiration. If it performs photosynthesis, they're all carried on by a structure called as mesosomes. I'm just reminding you once again that prokaryotic cells do not have any membrane-bounded cell organelles. No nucleus, no endoplasmic reticulum, Golgi complex, chloroplast, mitochondria. They are all absent. And hence, respiration, which is supposed to be done by the structure called as mitochondria, will be taken up by mesosomes. Similarly, if a bacteria is photosynthetic, photosynthesis has to be done by a structure called as chloroplast. And hence, chloroplast is absent in prokaryotes, and hence it will be taken up by mesosomes. So I hope you got the answer anywhere here. The answer should be A, that is flagellum is composed of filament, hook, and basal body. There is no structure called as lamellae here. Vesicles, tubules, they are all found in case of either endoplasmic reticulum or Golgi complex. And both endoplasmic reticulum and Golgi complex are absent in prokaryotic cells. Villi, I have told you already, these are the tiny air-like structures. Please do not think that villi are useful for locomotion like cilia. Cilia thara villi locomotion ge help agalla. Villi are meant for recombination. I told you fimbria also, these are meant for attachment. Filament, it is meant for locomotion. So answer should be A. Next question. Yeah. What is this? From which chapter is this question from? The chapter is biomolecules. That is first year's chapter, biomolecule, in which you have studied about proteins. You have studied that proteins are heteropolymers of amino acids. When you say polymers, which means they are made up of many monomeric units. And the monomeric units of proteins are amino acids, which are joined by a bond called as peptide bond by the process of dehydration. So what do you mean by heteropolymer? You know, amino acids are of 20 different types depending upon the functional groups which are present in amino acids. So heteropolymers means proteins are not made up of same type of amino acids. Protein is a chain of amino acids, but this chain is not made up of same type of amino acids, but it is a combination of different types of amino acids, and hence you call it as heteropolymer. And protein performs many functions, and those functions have been given in the form of table in your NCERT textbook. The same table is given here, but it is in jumbled form so that you have to look into the correct matching. I'm sure you remember the enzyme called as trypsin. Trypsin is an enzyme which is present in our digestive system, and it helps in digestion of proteins. I hope you know our pancreas produces this enzyme in the form of trypsinogen, which will be converted into trypsin. So it is produced in the form of trypsinogen, and it will be converted into trypsin. And it is converted into trypsin by what? By an enzyme called as enterokinase. Enterokinase is produced by duodenum. Enterokinase is produced by duodenum, whereas trypsinogen, which is an inactive enzyme, is produced by pancreas, which will be converted into active form, that is trypsin. And this, of course, happens in duodenum by an enzyme called as enterokinase. So, hagadre trypsin na yavudak match ಮಾಡ್ತೀರಾ? To what this will match with? Yeah, it works as enzyme. Just 1 minute. So trypsin works as enzyme. GLUT4, these are transporter molecules which will be present on cell membrane. And GLUT4, if this is a cell like this, on its membrane, you can find these structures which are called as GLUT4, which helps in transportation of glucose from outside to inside. So GLUT4 is a transporter molecule which is going to transport glucose from outside to inside. So GLUT4 enables glucose transport into the cell. I hope you remember about collagen. Collagen is the most abundant protein which is present in our body. And you know, collagen is also the part of ground substance which is present in connective tissues. ಇವುಗಳು connective tissue ನಲ್ಲಿರುತ್ತೆ, and the most abundant tissue in our body itself is connective tissue. And hence obviously collagen will be the most abundant protein which is present in our connective tissue. So collagen, it is the intercellular ground substance which is present in connective tissue. You remember the structure of antibody, which is an Y-shaped structure. It will be having 4 polypeptide chain like this, 2 heavy chains and 2 light chains. Together it is going to form an antibody which fights an infectious agent. So answer ಏನಾಗುತ್ತೆ ಹಾಗಾದ್ರೆ? A matches with R, 2 matches with S, 3 matches with Q, and hence the answer should be fourth one, that is D. Good. So today I can see only one person who is actively giving the answer, but rest of them are not So I'm just repeating the same thing today, that if you do not start answering, believe me, it is going to be very, very difficult in your exams. ಆನ್ಸರ್ ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ನಿಮಗೆ ಸ್ಪೀಡ್ ಮತ್ತೆ ಆಕ್ಯುರಸಿ ಬೆಳೆಯಲ್ಲ. ನೀವೇ ಟ್ರೈ ಮಾಡಬೇಕು ಆನ್ಸರ್ ಮಾಡಕ್ಕೆ. ಅದು ತಪ್ಪಾಗ್ಲಿ ರಾಂಗ್ ಆಗ್ಲಿ, ಡೋಂಟ್ ವರಿ, ಬಟ್ ಗಿವ್ ಯುವರ್ ಅಟೆಂಪ್ಟ್ ಆಫ್ಟರ್ ಲಾಜಿಕಲ್ ರೀಸನಿಂಗ್ ಟು ದಿಸ್. Don't just try to guess it and throw some answer. Try to understand the question and give the answer with some logical reasoning. ಕೊನೆಗೆ ಸಿಗ್ಲಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ anyway you have got no negative marking in case of CET, not for NEET. For CET anyway you don't have negative marks, so please try to answer. Yeah, the correct sequence of events in prophases. So this we discussed in the last class, if you remember. See, this is what is the advantage of looking into previous year questions. You will get an idea of what type of questions arises from a particular chapter. I told you last class also, this question is from a chapter called Cell Cycle and Cell Division. Question mainly comes from prophase and anaphase 1 of meiosis 1. So during prophase, we saw that it will be having different stages. I told you that there is a sentence to remember the exact sequence, like lazy zebras pack try diaper. So wherein lazy, you can say L as leptotin. What happens during leptotin is, it is chromosomes, or rather chromatin network, it is going to start condensing. It's going to start condensing. And what does Z stands for? Z stands for zygotin. And what happens during zygotin? The process of synapses, that is pairing of homologous chromosomes, takes place. And next is P, which stands for packetin. And what happens during packetin? The synapsed chromosomes, which will be having synaptonemal complex. And inside synaptonemal complex, it will be having an enzyme called as recombinase. And that helps in the process of crossing over between two homologous chromosomes. And then it enters into what is called as diplotin. D stands for diplotin, wherein after crossing over, they're going to start repelling from each other and they'll start appearing like X shape. And that is what you call it as chiasmata structure. So diplotin nalli chiasmata structures barate. And last, dia, it means diakinesis. And what happens during diakinesis is, the homologous chromosomes, after crossing over, they are going to undergo terminalization. Wherever they have attached, that point of attachment goes to the end of the chromosome and they will detach from each other. So condensation on bit 2, rest of them are all in the correct sequence in option A. Synapses, crossing over, chiasmata formation, terminalization. Please remember in which stage what happens. Synapsis takes place in zygotin, crossing over takes place in packetin, chiasmata formation in diplotin, terminalization takes place in diakinesis. So answer is A. I can see some of you answering as C also. So please, I hope you are understanding C is not the correct answer. Chiasmata agodu at the later stages. Next question. Yeah. The enzyme that is not found in C3 plants. Again, see what is the advantage. We discussed about C3 and C4 plants in last class. I hope you remember that. C3 plants nalli what happens is, I will try to explain this mechanism, try to understand this carefully. Okay, yeah, here we go. So let us try to compare C3 and C4 cycles together. Then we'll come to the question. Let us say these are carbon molecules, carbon atoms. There are fourth and fifth carbon atoms. So this molecule is called as ribulose 1,5 bisphosphate. It is called as bisphosphate because it will be having one phosphate at the carbon 1 and another phosphate at carbon 5. So what happens in the next step is one carbon in the form of carbon dioxide is added to this. And the enzyme which helps in this is called as rubisco. Ribulose bisphosphate carboxylase oxygenase enzyme. And this is the most abundant enzyme on the planet Earth, or most abundant protein on this planet Earth. So rubisco adds one of the carbon dioxide to this 5 carbon molecule. It is going to add here. But it is going to become highly unstable with the addition of 6th carbon, and it will be broken down into 2 molecules of 3 carbon. 3 carbon ಇರೋ 2 molecule ಆಗುತ್ತೆ. ಎರಡರಲ್ಲೂ 3ನೇ ಪೊಸಿಷನ್ ನಲ್ಲಿ ಫಾಸ್ಫೇಟ್ ಇರುತ್ತೆ. And this molecule is called as 3-phosphoglyceric acid. full ಬರ್ದ್ಬಿಡ್ತೀನಿ. 3-phosphoglyceric acid. So this step is called as carboxylation ಅಂತ ಕರೀತಾರೆ because carbon dioxide is added to this. The first step happens is carboxylation. Second step is reduction. What happens during reduction is, reduction ಆಗುವಾಗ NADPH2, which is produced as a part of light reaction, it will get oxidized into NADP. ಇದು ಆಕ್ಸಿಡೈಸ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಇಟ್ ಇಸ್ ಗಿವಿಂಗ್ ಇಟ್ ಇನ್ ಟು ಫಾಸ್ಫೋಗ್ಲಿಸರಿಕ್ ಆಸಿಡ್ ಅಂಡ್ ಕನ್ವರ್ಟಿಂಗ್ ಫಾಸ್ಫೋಗ್ಲಿಸರಿಕ್ ಆಸಿಡ್ ಟು ಆಲ್ಡಿಹೈಡ್, which means phosphoglyceric acid is getting reduced. Reduce ಆಗಕ್ಕೆ ಎಲೆಕ್ಟ್ರಾನ್ ಎಲ್ಲಿಂದ ಬರ್ತಾ ಇದೆ? NADPH2. And it is going to make use of ATP, which will be converted into ADP plus inorganic phosphate, and it gets energy from this. And hence it will be broken down into, not broken down, it will be converted into next molecule, which will be having again 3 carbons in each one of them. But since it is reduced now, since it is reduced from acid to aldehyde, this molecule is called as 3-phosphoglyceraldehyde. 3-phosphoglyceraldehyde. Now, when 6 such events takes place, 2 of them are used for production of glucose. Rest of them it will be start to recycling back. ಈ ತರ recycling ಆಗುವಾಗ it is going to produce an 5 carbon molecule, which will be having a phosphate group at first position, and will be converted back into ribulose 1,5 bisphosphate by using one more ATP, which will be converted into ADP. So I'm just again pointing out the steps. First step that happens here is called as carboxylation event. Second step that has happened here, it is called as reduction. And this step, the last step, this is carboxylation, this is reduction, and this is regeneration. And I hope you agree with this. This cycle is called as C3 cycle. Why it is called as C3 cycle? Because after the addition of carbon dioxide, the first stable compound, it will be having 3 carbon in it. 3 carbon ಇರೋದ್ರಿಂದ ಇದನ್ನ C3 cycle ಅಂತ ಕರೀತಾರೆ. But C3 cycle can lead to photorespiration if rubisco adds oxygen instead of carbon dioxide. Carbon dioxide add ಮಾಡೋ ಬದಲು oxygen add ಮಾಡಿದ್ರೆ ಈ cycle ಎನರ್ಜಿನ ವೇಸ್ಟ್ ಮಾಡುತ್ತೆ. Because of this, to avoid this photorespiration, plants will have what is called as C4 cycle. So what happens in case of C4 cycle? We saw this when we were discussing about Kranz's anatomy in the last class. Instead of rubisco, it will be having an enzyme called as PEP. Please remember, it will be having an enzyme called as PEP, phosphoenol pyruvate. PEP, which stands for phosphoenol pyruvate carboxylase. ಹಾಗಾದ್ರೆ phosphoenol pyruvate carboxylase ಯಾವ್ದ್ರಲ್ಲಿ ಇರೋದು ಅಂತ ಹೇಳಿದ್ರೆ C4 plants. ಅದರಲ್ಲೂ ಯಾವ್ದ್ರಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರೆ mesophil cells of C4 plants. Whereas ಇಲ್ಲಿ C3 cycle ನಡೆಯೋದ್ರಿಂದ rubisco will be present only in the bundle sheets. Again, important, ಜ್ಞಾಪಕ ಇಟ್ಕೊಬೇಕು, ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದ್ರೆ very good. ಇಲ್ಲ ಅಂದ್ರೆ at least ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. C4 plants ಅಲ್ಲಿ you can find a special enzyme which is called as PEP carboxylase, and that PEP carboxylase is present only in mesophils, whereas rubisco, the other hand, rubisco will be present in which one? In the bundle sheet cells. So PEP carboxylase C4 ಮಾತ್ರ ಇರೋದ್ರಿಂದ, C4 plants ಅಲ್ಲಿ ಮಾತ್ರ ಇರೋದ್ರಿಂದ, I'm sorry, 1 minute. Since it is present only in C4 plants, so I hope you can answer this now. Where is that question? Yeah. The enzyme that is not found in C3 plants. Can you give me the answer? Only 2. See, you're again misunderstanding it. Question is enzyme that is not found in C3 plants. ATP synthase, it is required for synthesis of ATP. It is present in both C3 as well as C4. Rubisco, it is present in both C3 as well as C4. That's why I told you to please concentrate and remember that rubisco, that is ribulose 1,5 bisphosphate, ribulose bisphosphate carboxylase, it is present in C3 plants, but it is present only in bundle sheath cells of C4 plant. ಯಾವ್ದ್ರಲ್ಲಿ ಮಾತ್ರ ಇರುತ್ತೆ ಅಂದ್ರೆ bundle sheath cells ಅಲ್ಲಿ ಇರುತ್ತೆ, but it is present in all mesophil cells. All mesophil cells of C3 cycle ಎಲ್ಲಾ ಕಡೆನೂ ಇರುತ್ತೆ, but C4 ಅಲ್ಲೂ ಇರುತ್ತೆ, but it is found only in case of bundle sheath cells. NADP reductase is an enzyme which is required in light reaction. Light reaction ಅಲ್ಲಿ non-cyclic photophosphorylation, cyclic photophosphorylation ಅಂತ ಓದಿದ್ದೀರಾ. NADP ಅನ್ನ to convert it into NADPH, it is going to make use of NADP reductase, which is present again in C3 as well as C4. So one which is not found in C3 but present only in C4. That too in where? In which cells of the C4? It is present only in the mesophil cells of C4. Bundle sheaths allirodu rubisco. Mesophyll cells alirodu PEP carboxylase. So our answer should be D. I hope you understood this. Very good. Next question. Yeah, so location of the cells given in column 1 with the function in column 2. Mitochondrial matrix from the cell cycle and cell division, or you can consider this better as the chapter as respiration in plants. While a cell undergoes the process of respiration, it has got two steps. One is called as glycolysis. After glycolysis, if it is aerobic respiration, it will undergo what is called as Krebs cycle, or also called as citric acid cycle, and then it undergoes electron transport chain. Now, glycolysis is the process where glucose is broken down into pyruvic acid. Glycolysis nalli ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ glucose is broken down into two molecules of pyruvic acid. This pyruvic acid, it will be converted into, please remember all these steps. Since it is important, I am telling this not for just wasting the time. So pyruvic acid is converted into acetyl-CoA with the release of carbon dioxide, as well as NAD is converted into NADH2. So decarboxylation ಆಗುತ್ತೆ as well as oxidation ಆಗುತ್ತೆ. ಈ ಸ್ಟೆಪ್ ಅನ್ನು ಆಕ್ಸಿಡೇಟಿವ್ ಡಿಕಾರ್ಬಾಕ್ಸಿಲೇಷನ್ ಅಂತ ಕರೀತಾರೆ. Once if it produces acetyl-CoA, and the location of this takes place in the mitochondria. And next step, that is Krebs cycle. We will see about Krebs cycle today. Krebs cycle takes place in the matrix of mitochondria. What do you mean by matrix of mitochondria? If this is a mitochondrial outer membrane, this is the inner membranes which are folded like this. These folded inner membranes are called as cristae. This inner part is called as mitochondrial matrix. That is where the Krebs cycle takes place. And during Krebs cycle, what happens is it is going to produce carbon dioxide, and it also produces NADH2s. NADH2 is a very important molecule here, which stands for nicotinamide adenine dinucleotide in its reduced form. And finally, it undergoes the last step, which is called as electron transport chain. And this takes place in the inner membrane of mitochondria. So what is the product of electron transport chain is ultimately electron is added to oxygen, converting oxygen to water. And during this, there is an F0, F1 particles, which are also referred as ATP synthase. ATP synthase, which are important for ATP synthesis. Please understand what I am telling, out of which F0, it will be found in the membrane, and the F1 will be present in the matrix. Membranes of inner mitochondria, F0 idre, F1 particle matrix ಒಳಗಡೆಗೆ project ಆಗಿರುತ್ತೆ. Now, I hope you can answer this. ಈಗ ಆನ್ಸರ್ ಮಾಡ್ಬೇಕು. ಈಗಲೂ ನೀವು ಆನ್ಸರ್ ಮಾಡಲಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಇಟ್ ಶೋಸ್ ಯುವರ್ ಲೇಸಿನೆಸ್ ಆರ್ ಲೆಥಾರ್ಜಿ and it will be difficult. Yochne maadi answer kodi iga bega. Process of glycolysis takes place in cytoplasm. ಹಾಗಾದ್ರೆ ಸೈಟೋಪ್ಲಾಸಮ್ ಅಲ್ಲಿ ನಡೆಯೋದೇನು ಅಂತ ಹೇಳಿದ್ರೆ ಗ್ಲೈಕಾಲಿಸಿಸ್. ಗ್ಲೈಕಾಲಿಸಿಸ್ ಇಂದ ಬರೋದೇನು ಅಂತ ಹೇಳಿದ್ರೆ ಪೈರುವಿಕ್ ಆಸಿಡ್. ಪೈರುವಿಕ್ ಆಸಿಡ್ ಇಂದ ಅಸಿಟೈಲ್ ಕೋಯೆ ಬರುತ್ತೆ. ಅಸಿಟೈಲ್ ಕೋಯೆ then enters into Krebs cycle which takes place in the matrix of mitochondria. ಹಾಗಾದ್ರೆ matrix of mitochondria it undergoes Krebs cycle. What are the important product of Krebs cycle is NADH2. NADH2. This NADH2 enters into electron transport chain. Where does the electron transport chain takes place? It takes place in the inner membrane. So F0 F1 particle, it is for ATP synthesis. So which is also called as ATP synthetase enzyme itself. Inner mitochondrial membrane, you can find electron transport chain taking place. Hagadre answer should be A. I can see username by Punit giving it as D. Let us check it. Mitochondrial matrix P2 matches with R3 matches with yes. Inner mitochondrial membrane is with Q. Answer should be A. Punit Chavan. B alri adu. It should be A. I hope you agree. Okay. Next question. This question is from the chapter Plant Growth and Development. And in plant growth and development, you have studied about different types of plant growth regulators. So question is about plant growth regulators. You have studied about 5 different types of plant growth regulators. Which are those? Auxin, cytokinin, gibberellic acid, ethylene, and abscisic acid. These are the 5 different types of plant growth regulators. In this, what you have studied is about its chemical property first. Question enadru irli. Don't worry about the question right now. Please listen to me. Don't look at the question right now. Please listen to me what I am telling. Screen ಅಲ್ಲಿ ನೋಡ್ಕೊಂಡು ಗಮನ ಇಟ್ಟು ಕೇಳಿಸ್ಕೊಳ್ಳಿ. Question ಬಗ್ಗೆ ತಲೆ ಕೆಡಿಸ್ಕೊಂಬೇಡಿ. So you have studied about 3 different aspects of all these 5 plant growth regulator, out of which the first one that we have studied is about the discovery of all these plant growth regulators. Discovery of all these plant growth regulators. Auxin, the first attempt to discover the auxin, not intentionally but accidentally, it was discovered by Darwin and his son, Charles Darwin, and his son, Francis Darwin. When they were working on, please remember all this what I'm telling. Then they were working on a plant called as canary grass. Canary grass. When they were working on the coleoptile of canary grass, they found that the grass used to bend towards light only when it had shoot tip. Shoot tip and tegdaakbitre plant was not bending towards light. So they said there is something present at the tip of the plant which is responsible for bending. Anta helbitru ashte Darwin. But the most successful person to discover the auxin was F.W. Wendt. Remember the name? F.W. Wendt, when he was studying about coleoptile of oat. Canary grass mele work madiddu Darwin and his son. But oat plant mele work madiddu F.W. Wendt, and the credit for discovery of auxin goes to F.W. Wendt. So So credit for discovery of cytokinin goes to Skoog and Miller. These two scientists discovered cytokinin. I hope you remember, gibberellic acid was discovered by Kurosawa. When Kurosawa was working on a disease called as Bakane disease, foolish seedling disease, which is caused by a fungus called as Gibberella fugicori, he discovered it. Ethylene was discovered by a scientist called as Cousins. Abscisic acid was discovered by 3 different scientists by 3 different names. So you don't have to worry about who discovered abscisic acid. Next thing that you have studied is about its chemical properties. Please remember all this. About its chemical property, auxin is derived from an amino acid called as tryptophan. Tryptophan is an aromatic amino acid which will be having indole ring in it. On the aromatic ring irutte, indole ring anta. Adrinda auxin produce agutte. You know example of auxin such as indole acetic acid, indole butyric acid, naphthalene, indole butyric acid, naphthalene acetic acid, 2,4-dichlorophenoxyacetic acid. Cytokinin is a derivative of adenine. Nimge adenine ಜ್ಞಾಪಕ ಇರಬಹುದು. Adenine is a type of purine. ಅದರಿಂದ cytokinin produce ಆಗಿರುತ್ತೆ. Gibberellic acid is a derivative of terpene rings. Ethylene is the most simplest plant growth regulator, which is in gaseous form, which is ethylene, that is C2H4. Abscisic acid is on the other hand, it is derived from a pigment called as carotenoid. ಜ್ಞಾಪಕ ಇರಬಹುದು, carotenoid is an accessory pigment that you find in photosynthesis. ಅದರಿಂದ abscisic acid produce ಆಗುತ್ತೆ. ಇದನ್ನ ಏನಕ್ಕೆ ಇಷ್ಟು ಬರ್ದಿದ್ದೀನಿ ಅಂತ ಹೇಳಿದ್ರೆ, they may ask question in the form of match the following. ಒಂದು ಕಾಲಮ್ ನಲ್ಲಿ ಪ್ಲಾಂಟ್ ಗ್ರೋತ್ ರೆಗ್ಯುಲೇಟರ್ ಕೊಟ್ಟು ಇನ್ನೊಂದು ಕಾಲಮ್ ನಲ್ಲಿ ಅದನ್ನ ಡಿಸ್ಕವರ್ ಮಾಡಿದವ್ರು ಯಾರು ಅಂತ ಕೊಡ್ಬೋದು ಜಂಬಲ್ ಮಾಡ್ಕೊಂಡು, ಅಥವಾ ಒಂದು ಕಾಲಮ್ ನಲ್ಲಿ ಪ್ಲಾಂಟ್ ಗ್ರೋತ್ ರೆಗ್ಯುಲೇಟರ್ಸ್ ಕೊಟ್ಟು ಇನ್ನೊಂದು ಕಾಲಮ್ ನಲ್ಲಿ ಅದ್ರ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅಥವಾ ಯಾವ್ದ್ರಿಂದ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿರುತ್ತೆ ಅಂತ ಕೊಡ್ಬೋದು. They may ask you to match the following. Now, coming to the more important part from this, you have studied about what are the functions of each one of them. ಪ್ರತಿಯೊಂದ್ರದ್ದು ಏನ್ ಫಂಕ್ಷನ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದನ್ನ ಓದಿದಿರ. Now, auxin, I'm just going to tell orally. I hope you are going to remember it. If you have any doubts, you can let me know. Auxin induces apical dominancy. Auxin induces cell division, cell elongation, and cell differentiation. One more important property of auxin is auxin induces flowering. Auxin induces flowering. In case of mango, pineapple, etc., auxin also induces a phenomenon called as parthenocarpy. I hope you know what is parthenocarpy. It is formation of fruits without fertilization is called as parthenocarpy. It induces parthenocarpy in case of tomato. Gibberellic acid also induces parthenocarpy, but induces parthenocarpy in case of grapes. Auxin is also used for getting weed-free lawns because it is going to act as herbicides. Cytokinin induces shooting, auxin induces rooting. ಹೊಸ ರೂಟ್ಗಳು ಬರ್ಲಿಕ್ಕೆ ಆಕ್ಸಿನ್ ಹೆಲ್ಪ್ ಮಾಡಿದ್ರೆ ಹೊಸ ಶೂಟ್ಗಳು ಬರ್ಲಿಕ್ಕೆ ಸೈಟೋಕೈನಿನ್ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ. Auxin, if it induces apical dominancy, cytokinin is going to break apical dominancy. If you want to know what is apical dominancy, I will tell you apical dominancy shortly. Gibberellic acid ತುಂಬಾ important function ಅಂತ ಹೇಳಿದ್ರೆ it induces seed germination. Gibberellic acid induces seed germination, it induces cell elongation. Internode ಅನ್ನ elongate ಮಾಡೋದ್ರಿಂದ gibberellic acid is used in sugarcane farming. You know, If internode elongates, then the sugarcane production improves. We can improve up to 20 tons of sugarcane can be improved in productivity per hectare by using gibberellic acids. Ethylene, on the other hand, it is a plant growth regulator which promotes fruit ripening. Fruit ಹಣ್ಣಾಗ್ಲಿಕ್ಕೆ help ಮಾಡುತ್ತೆ ethylene by what is called as climacteric respiration. Ethylene is also a growth inhibiting plant growth regulator. Ethylene helps in production of flower in case of pineapple. Just like auxin, ethylene is also going to induce flowering. Abscisic acid is a growth inhibiting plant growth regulator. It closes the stomata. Neer kadme idaga stomata na close madi, it is going to help in preventing the water loss. And then abscisic acid is called as water stress hormone. Now let us try to answer it. Kinetin is a derivative of adenine, which is pyrimidine. Adenine is not a pyrimidine. I hope you know adenine and guanine. Adenine and guanine, both of them are the examples of purine. But ಇಲ್ಲಿ ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ pyrimidine ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. It is not correct. First one is not correct. So idu question is about identifying the incorrect statement. The technique of decapitation is widely used in tea plants. Now I will explain you about what do you mean by apical dominancy. Auxin induces what is called as apical dominancy. And how it induces, or what do you mean by apical dominancy is, if you observe any plant which is growing like this, you can find leaf which are produced at the regular intervals. Wherever leaves is there, at the axis of leaf, you can see an meristematic tissue which is called as axillary bud anta karitare. This is called as axillary bud. There is one bud, it will be at the tip, which is called as apical bud. So auxin is produced at the growing tip, especially in the apical bud, which means auxin concentration, it will be highest in the tip, and it keeps on reducing as we move towards downwards. ಕೆಳಗೆ ಬರ್ತಾ ಬರ್ತಾ auxin concentration ತುಂಬಾ ಜಾಸ್ತಿ ಇದ್ರೆ high concentration at the tip, but at the bottom it will be less. Now wherever the concentration of auxin is high, it will not let the apical buds to grow. Dominancy anta helidre bossism madodu. It is not going to let others to grow. Apical bud, it will not let the axillary bud to grow. Why it will not let to grow? Because wherever apical bud is there, the concentration of auxin, it will be high. But you might have observed in plants, as the plants keeps on growing, the axillary bud which is present towards the lowermost part, they are going to start growing like this. ಕೆಳಗಡೆ ಇರೋದು ಬೆಳೆಯಕ್ಕೆ ಶುರು ಆಗುತ್ತೆ. Why? Because the concentration of auxin is low, which means due to presence of high concentration of auxin at the apical bud of a plant, apical bud, it will not let the axillary bud to grow. Now let us try to understand like this. Suppose if you break, or suppose if you cut, suppose if you cut off this topmost part, idan cut ಮಾಡ್ತೀರಾ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. If you remove this part, what will you lose? You are going to lose apical bud. If you lose apical bud, which it means auxin is not produced in high concentration here, which means auxin concentration reduces. And when auxin concentration reduces, these will grow, which means it has lost apical dominancy. If you want to lose apical dominancy without cutting this, ಇದನ್ನ ಕಟ್ ಮಾಡ್ದಲೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಎಪಿಕಲ್ ಡಾಮಿನೆನ್ಸಿನ ಕಳ್ಕೊಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, you just have to spray this with an hormone called as cytokinin. A plant growth regulator called as cytokinin is going to break the apical dominance. Otherwise, you just have to cut it. If you remove this part, then auxin is going to be less. Auxin is going to be less. Then this is going to grow. Now, what happens in tea plantation? Tea ಬೆಳೆಯೋ ಕಡೆ ಏನ್ ಮಾಡ್ತಾರೆ? ಟೀ ಸೊಪ್ಪನ್ನ ಮೇಲ್ಗಡೆ ಕೀಳ್ತಾ ಹೋಗ್ತಾರೆ. They are going to keep on pinching off the apical bud. ಮೇಲ್ಗಡೆ ಇರೋ ಎಲೆಗಳನ್ನ ಕೀಳ್ತಾ ಹೋಗ್ತಾರೆ ಟೀ ಗಿಡದಲ್ಲಿ. ಮೇಲ್ಗಡೆ ಎಲೆ ಕಿತ್ತಾಕ್ಬೋದ್ರು ಅಂತ ಹೇಳಿದ್ರೆ, if they pinch off the topmost part of the plant, which means they are going to lose apical bud. If they lose apical bud, it means they have lost auxin, and hence the shoot starts emerging from the axillary buds, and hence tea, which is supposed to grow like a tall plant like this or a tall tree like this, itara udda belkondu hogbekittu tea plant. But ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, it will keep on branching. You can find lots of branches in the tea because it is going to lose apical dominancy by removing the topmost part of the leaves. Now, if you look at this one, the technique of decapitation. Decapitation ಅಂತ ಹೇಳಿದ್ರೆ ತಲೆ ತೆಗೆದಾಕೋದು ಅಂತ. In other words, decapitation means removal of apical bud. So technique of decapitation is widely used in tea plants. Yes, that is why tea plants will not grow tall. It can grow tall, but it will not grow tall because it is going to keep on decapitation. But most important, you will artha madkombekagirodu, because of this, it is going to lose apical dominancy. So second statement is correct. Ethylene is a gaseous plant growth regulator. I already told you with respect to chemical property. Second statement correct irodrinda, question is incorrect and kandidiyebekagirodrinda illi second ide, A cannot be correct answer. So ethylene is a gaseous plant growth regulator. 3 nu correct ide, A nu correct agalla, B nu correct agalla, C nu correct agalla. Answer should be D. Use of gibberellic acid hastens the malting process in brewing industries. When seed, gibberellic acid induces seed germination. When the seed is germinating, it is going to convert the starch present in its cotyledons or endosperm into maltose by an enzyme called as amylase. Gibberellic acid amylase anna produce marsi, and this amylase will convert starch into maltose. ಹಾಗಾದ್ರೆ ಮಾಲ್ಟಿಂಗ್ ಪ್ರೋಸೆಸ್ ಗೆ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ. ಆ ಮಾಲ್ಟೋಸ್ ಅನ್ನ ತಗೊಂಡು ಫರ್ಮೆಂಟೇಶನ್ ಮಾಡಿ ಆಲ್ಕೋಹಾಲಿಕ್ ಬೆವರೇಜಸ್ ಗಳನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಫೋರ್ತ್ ಒನ್ ಇಸ್ ಆಲ್ಸೋ ಕರೆಕ್ಟ್. Abscisic acid is a growth promoting plant growth regulator. No. Abscisic acid is a growth inhibiting plant growth regulator. Whereas these 3 hormones, auxin, cytokinin, gibberellic acid, all of them are growth promoting plant growth regulators. Ethylene ಸ್ವಲ್ಪ ಪ್ರಮೋಟ್ ಮಾಡುತ್ತೆ, ಸ್ವಲ್ಪ ಇನ್ಹಿಬಿಟ್ ಮಾಡುತ್ತೆ, ಎರಡೂ ಕಡೆ ಬರುತ್ತೆ ethylene. So fifth one, abscisic acid is not a growth promoting hormone, which means it is incorrect. So the answer should be D. The answer is 1 and 5. Correct. Answer is 1 and 5. Only one person has given the answer. Fine. No problem. Next question. Idannantu ನೀವು try ಮಾಡಿ ಹೇಳಲೇಬೇಕು. You have to give me the answer for this question. We'll wait for 1 or 2 minutes. You have to give me the answer for this question. I'm not getting any answers. I'll start giving you the hint. Let us see when you will answer this. This question is from the chapter Body, Fluids, and Circulation. In body fluids and circulation, you have studied two parts. Different types of body fluids. Different types of body fluids includes blood and tissue fluid. And you have studied about blood, that it will be having plasma, RBC, WBC, platelets. We saw this yesterday also. Under circulation, you have studied about the structure of heart and how the heart is going to function. So if you look at the human heart, it will be having 4 chambers. We saw this in the last class also. It will be having 4 chambers, and those chambers includes the right atrium, left atrium, and then there is septa, interventricular septa, which is going to divide left ventricle and right auricle. There is a blood vessel which moves away. There is a blood vessel which moves away from here, right atrium in the blood and check. This is called as pulmonary artery, which carries deoxygenated blood to lungs. And one blood vessel, which is a large blood vessel, it carries the blood out of left ventricle. This is called as aorta. What do you mean by stroke volume first? It is the volume of blood. Stroke volume is volume of blood pumped by each ventricles per beat. ಒಂದ್ಸರಿ ಹೃದಯ ಹೊಡ್ಕೊಂಡಾಗ ಎಷ್ಟು ವಾಲ್ಯೂಮ್ ಲೆಫ್ಟ್ ವೆಂಟ್ರಿಕಲ್ ಇಂದ ಮತ್ತೆ ರೈಟ್ ವೆಂಟ್ರಿಕಲ್ ಇಂದ ಆಚೆಗೆ ಹೋಗುತ್ತೋ ಅದನ್ನೇ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಸ್ಟ್ರೋಕ್ ವಾಲ್ಯೂಮ್ ಅಂತ ಕರೀತಾರೆ. ಸೊ ಇಟ್ ಇಸ್ 55 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ಲಿ. ಕ್ವಶನ್ ಇಸ್ ಅಬೌಟ್ ಕಾರ್ಡಿಯಾಕ್ ಔಟ್ಪುಟ್. Question is about cardiac output. What do you mean by cardiac output? It is the volume of blood. It is the volume of blood that is pumped out of each ventricles per minute, not per beat. Illi per beat. Yaudake? For stroke volume, it is for per beat. Illi per minute. Hagadre cardiac output, it will be equal to stroke volume plus number of heartbeat per minute. At least now I want you people to answer. Only Rachana RJ has answered it, others not yet attempted. ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಪ್ರಕಾರ ಸ್ಟ್ರೋಕ್ ವಾಲ್ಯೂಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ನಂಬರ್ ಆಫ್ ಹಾರ್ಟ್ ಬೀಟ್ ಪರ್ ಮಿನಿಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ದೆನ್ ಯು ಹ್ಯಾವ್ ಟು ಗಿವ್ ಮಿ ದ ಆನ್ಸರ್. ನೀವೆಷ್ಟು ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತಿರೋ ಅಷ್ಟು ಕಡಿಮೆ ಕ್ವಶನ್ಸ್ ಗಳು ಸಾಲ್ವ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ. What is the stroke volume according to them? It is 55. What is the number of heartbeat? Number of heartbeat is 70. Then how much? Sina? I'm very poor in mathematics. I hope you can calculate and tell me quick. Looks like you people are more poor than me. Okay, so the answer should be C. So, but I hope you understood what do you mean by stroke volume and what do you mean by cardiac output. Fine. Next. Next question, please. Answer. In standard ECG, one of the following function of its component is not correctly interpreted. So just try to concentrate first over here and then we'll go back to this question. ನಾನು ಹೇಳ್ತಾ ಇರೋದನ್ನ ಗಮನ ಕೊಟ್ಟು ಕೇಳಿಸ್ಕೊಳ್ಳಿ first. Try to understand what I'm telling first and then we'll go back to the questions. Suppose if this is a human heart, which we just now saw, it will be having 4 chambers. That is right auricle, left auricle, right ventricle, and left ventricle. You know, in this heart, there are, first of all, I hope you know, human heart is called as myogenic heart. What do you mean by myogenic? Myo anta ಹೇಳಿದ್ರೆ muscle, genic anta ಹೇಳಿದ್ರೆ generate ಮಾಡೋದು ಅಂತ. Whatever electric impulse is required for contraction of muscle, that electric impulse is generated by muscle itself. Cardiac muscles ಬೇಕಾಗಿರೋ electric impulse ಅನ್ನ cardiac muscle ಉತ್ಪಾದನೆ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. Then you call it as myogenic. Whereas cockroach heart is called as neurogenic, which means if a cockroach heart muscle has to contract, the electric impulse for contraction of cockroach heart has to come from neurons. It cannot generate by itself. So in this human heart, there are 2 important nodes. I hope you remember those nodes. One is present over here and the other one is present over here. First one that is present here, it is also called as pacemaker. That is called as cyanoatricular node. SAN anta ಕರೀತಾರೆ. Cyanoatricular node. And there is one more node here which is called as atrioventricular node anta ಕರೀತಾರೆ. Now, heart contraction or heart cardiac cycle. Heart's cardiac cycle, it will be having 3 events. First event, it is called as atrial systole, or also called as atrial muscles depolarization. ಅಂದ್ರೆ ಏಟ್ರಿಯಂಗಳ 2 chambers ಗಳು ಕಾಂಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ. Second event, it is called as ventricular systole, or you can say ventricular depolarization. Muscles ಗಳು activate ಆಯ್ತು ventricles. And the third one is combined diastole, wherein it will undergo what is called as repolarization. ಡಿಪೋಲರೈಸೇಷನ್ ಆಗಿದೆ, ಎರಡು ಚೇಂಬರ್ repolarization ಆಗುತ್ತೆ. Now follow this correctly. The first one to generate electric impulse is cyanoatricular node, which are going to send the electric impulse to both atrium. Then it undergoes atricular systole. And then electric impulse comes to this one, AV node. AV node will further generate electric impulse through bundle of is. Through bundle of is. It goes to both ventricles. ತರ ಎರಡು ವೆಂಟ್ರಿಕಲ್ಗೆ ಹೋಗುತ್ತೆ. ತರ ಎರಡು ವೆಂಟ್ರಿಕಲ್ಗೆ ಹೋದಾಗ ಏನಾಗುತ್ತೆ? It undergoes ventricular systole. And then finally, all the electric impulse, it will be lost. In the sense, muscles will get depolarized. If this is the condition, and now if you see the ECG of a human, a normal humans use ECG nalli ee tara barutte nimge. Wherein the first one, it is called as P wave. First one is called as P wave. Next, you have got Q, R, and S complex. Q, R, and S complex together. And then there is T wave. P wave is nothing but atricular systole. P wave is nothing but atricular systole. You know what is electrocardiogram is? It's a measurement of electric impulse. It is just the measurement of electric impulse generated from these SA node and AV node. So P wave it represents the atricular systole, which means atrial depolarization, because of which both the chambers andre both right atrium and left atrium, both of them are going to contract. Next, QRS complex. QRS complex represents ventricular systole, which means now electric impulse from AV node, it is coming to both ventricles. And T wave represents diastole, combined diastole, or muscles will undergo repolarization. Now, I want you to attend the question. First one, P wave is contraction of only left atria. Bari left atria, right atria, left ventricle, right ventricle, yavaglu agala. Adre ಎರಡು ಏಟ್ರಿಯಾಗಳು ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗುತ್ತೆ, ಅಥವಾ ಎರಡು ವೆಂಟ್ರಿಕಲ್ಗಳು ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗುತ್ತೆ, ಅಥವಾ ಎಲ್ಲಾದು ಡಯಾಸ್ಟೋಲ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ನಾಟ್ ಕರೆಕ್ಟ್ಲಿ ಇಂಟರಪ್ಟೆಡ್. ಇದು ಕರೆಕ್ಟ್ಲಿ ಇಂಟರಪ್ಟೆಡ್ ಅಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಆನ್ಸರ್ ಶುಡ್ ಬಿ ಎ. Now, what does QRS complex represents? QRS complex represents ventricular systole. Systole andre gottirbodu nimge, it is nothing but contraction, which means this is correct. Question is about identify not correct. E is end of systole. Systole ಆದ್ಮೇಲೆ ಏನ್ ಬರ್ಬೇಕು? Systole ಆದ್ಮೇಲೆ ಬರೋದು diastole. Diastole represents the end of systole, and P wave represents the end of systole. Correct statement. P is contraction of both atria. ಎರಡು ಏಟ್ರಿಯಾಗಳು ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗುತ್ತೆ, ಯಾಕೆಂದ್ರೆ SA node ಇಂದ electric impulse ಬರುತ್ತೆ. So the correct answer for this question then should be A. Can I get a quick reply? Rachana sir, maybe answer B or may not be. No, B cannot be correct answer. No. Rachana, understand the question. Question ಏನಿರೋದು? What is the question? One of the following function of its component is not correctly interrupted. QRS complex is correctly interrupted. QRS complex is the contraction of ventricle. It is correctly interrupted. Question is about not correctly interrupted. So P, it represents the contraction of both atria. But illenanta kottidare only left atria anta kottidare. So answer should be A. Okay, fine. I hope others. Yeah, Punit Chavan, it is correct. Your answer is correct. And I hope others have understood this. Can I get a quick reply if any doubts are there? Next question. Doubts idre, please let me know. Yeah, the next question is about from the chapter called the last chapter of first year. That is chemical control and integration, or chemical coordination and integration. Here you can see on column 1, they have given different types of hormones produced in humans. And in 2, they have given their function. Catecholamine is an hormone which is produced during stress, and hence it is called as stress hormone. MSH. MSH stands for melanocyte stimulating hormone. And this is, of course, melanocytes produces a pigment called as melanin. And I hope you remember melanocyte is produced from the intermediate lobe of pituitary gland. Anterior, posterior, madhya iruttala, ಆ lobe ಇಂದ melanocyte stimulating hormone produce ಬರುತ್ತೆ. ಅದರಿಂದ melanocyte skin ಮೇಲಿರೋ melanocytes ಗಳನ್ನ stimulate ಮಾಡಿಸಿ, from that it is going to produce a pigment called as melanin. If it produces more melanin, our skin becomes dark. If it produces less melanin, our skin becomes white. So MSH, that is melanocyte stimulating hormone, is for pigmentation. Thymosin is an hormone which is produced by thymus gland. Thymus gland helps in maturation, or rather, maturation and differentiation of T cells. You know, in our immune system, we have got 2 types of cells. One is T cells and the other one is B cells, where B cells gets differentiated or matured in bone marrow, whereas T cells gets matured in thymus. I hope you also remember the size of thymus keeps on reducing as the person gets older. ವಯಸ್ಸಾಗ್ತಾ ಆಗ್ತಾ ಥೈಮಸ್ಸಿನ ಗಾತ್ರ ಚಿಕ್ಕದಾಗ್ತಾ ಹೋಗುತ್ತೆ. ಅದರಿಂದ ಥೈಮೋಸಿನ್ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಅದರಿಂದ ಟಿ ಸೆಲ್ಸ್ ಗಳು ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. And hence our immune system is going to become weak as a person become older. Melatonin, I hope you remember, thymosin is produced from a structure called as thymus. Melatonin, on the other hand, it is produced by it's produced by an hormone called as pineal gland. And I hope you know these pineal glands are present in brain. And melatonin, which is produced here, it is going to control our sleep and wake up cycle. ನಿದ್ದೆ ಬರ್ಸೋದು ಮತ್ತೆ ಎಚ್ಚರ ಮಾಡಿಸೋದಕ್ಕೆ ಹಾರ್ಮೋನ್ ಯಾವ್ದಿರೋದು ಅಂತ ಹೇಳಿದ್ರೆ, it is melatonin. Yeah, what is the answer now? Good. At least 2 of you are answering. The answer should be A. Next question. Just let me remove your questions. Okay. So, assertion. In bryophytes and pteridophytes, the number of male gametes produced is several thousand times the number of female gametes produced. It is a correct statement. Why? You know, one of the example of bryophytes is Markensia. which are also called as liverworts. If this is a liverworts like this, liverwort is an example of dioecious hormone, dioecious plant, which means the male and female reproductive structures are produced in two separate structures. If one produces archegoniophore, the other one will be producing antheridiophore. In other words, if one produces male reproductive structure, other produces female reproductive structure. Inside female reproductive structure, you can find a flask-shaped structure which is called as archegonium, multicellular flask-shaped structures which are called as archegonium. Inside archegonium, you will find a single cell which is going to act as egg. On the other hand, male reproductive structure will produce an motile male gametes, which are called as antherozoids. These are called as antherozoids. Now, you know both bryophytes and pteridophytes depends on water for the purpose of fertilization. ಇದೆರಡಕ್ಕೂ ಏನು ಬೇಕೇ ಬೇಕು ಅಂದ್ರೆ ನೀರು ಬೇಕು. ಏನಕ್ಕೆ? Because water is going to be media for swimming of antherozoids so that they will reach the neck of this egg. ಅದಕ್ಕೋಸ್ಕರನೇ ಬ್ರಯೋಫೈಟ್ಸ್ ಅನ್ನ they are called as amphibians of plant kingdom ಅಂತ ಕರೀತಾರೆ. Because bryophytes and also pteridophytes, they depend on water for completing their life cycle, especially for the purpose of fertilization. So which means if you want to increase the chances of fertilization, number of male gametes should be more. ಜಾಸ್ತಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ಬೇಕು. ಎರಡು ಕಾರಣಕ್ಕೆ, for two reasons. One, it increases the chances of fertilization. ಒಂದು ಕಾರಣ. Another reason is to compensate the loss of male gametes. Male gametes ನೀರಲ್ಲಿ ಕಳೆದೋಗುತ್ತೆ. Many of the male gametes will be lost in water. To compensate that loss of male gametes, it is going to produce large number of male gametes. So assertion is correct. What is the reason? Large number of male gametes fail to reach female gametes during transportation, and hence to compensate that loss of gametes, it is going to produce large number of gametes. Answer. ಒಬ್ರು ಕೊಟ್ಟಿದ್ದಾರೆ ಬಿ ಅಂತ. Do you still think the answer is B? Whoever has given the answer, ಈಗಲೂ B ಅನ್ಸುತ್ತಾ ನಿಮ್ಗೆ? Still, Vidya, yes, equally. You are also telling B. See, ಏನಿದೆ answer? Option ಏನಿದೆ? Assertion is correct, but reason is incorrect ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಏನಲ್ಲಿ. But reason correct agide. So A cannot be correct answer. Both assertion and reason are correct. Not only correct, reason is also explaining the assertion. So the answer should be B. I'm sorry, correct. The answer should be B. Both assertion and reason are incorrect. No. Assertion is incorrect, but reason is no. Answer should be B. Rachana and others who have given the answer as A. ನಾನು ಸ್ವಲ್ಪ ಟೋನ್ ಚೇಂಜ್ ಮಾಡಿದೆ ಆಗ್ಲೇ. ದಟ್ ಡಸಂಟ್ ಮೀನ್ ದಟ್ ಯು ಶುಡ್ ಚೇಂಜ್ ದ ಆನ್ಸರ್. ಇಲ್ಲಿ ಎರಡು ಕರೆಕ್ಟ್ ಇದೆ, ಎರಡು ಬರೀ ಕರೆಕ್ಟ್ ಇರೋದಲ್ಲ. ರೀಸನ್ ಇಸ್ ಆಲ್ಸೋ ಎಕ್ಸ್ಪ್ಲೈನಿಂಗ್ ದ ಅಸರ್ಷನ್, ಅಂಡ್ ದೆನ್ಸ್ ದ ಆನ್ಸರ್ ಶುಡ್ ಬಿ ಬಿ ಆಸ್ ಇಟ್ ವಾಸ್ ಟೋಲ್ಡ್ ಬೈ ಫಸ್ಟ್ ಪರ್ಸನ್. ಮತ್ತೆ ವಿದ್ಯಾ ಅವ್ರ ಇಬ್ರು ಏನ್ ಕೊಟ್ಟಿದಾರೋ ಆನ್ಸರ್ ಇಸ್ ಕರೆಕ್ಟ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. In the given diagram, identify the parts labeled as A, B, C, and D. First of all, understand this, that the given diagram is of monocot seed. The diagram is of monocot seed. The monocot, it will be having single cotyledon. Single cotyledon will be present, and that single cotyledon is this one. This is a single cotyledon, which you can say it as B. The cotyledon in case of monocots, it is also called as scutellum anta karitare, which means B is scutellum. Answer should be either A or it should be B. They will be having what is called as plumule, and it will be having radicle. You know, plumule later on gives rise to shoot, and radicle will later on gives rise to root. The protective sheets, that is A, on plumule, protective sheets which are present here, they are called as coleoptile. So A should be coleoptile. Again, the answer should be either A or it should be B. Protective sheets present on the radicle. Radical male protective sheets, they are called as coleorhiza, which means D should be coleorhiza. So answer then it should be A. C, on the other hand, it is pericarp. Pericarp, it will be thin and membranous. It is thin and membranous in case of monocotyledon seeds such as maize. ಇದರಲ್ಲಿ ಇನ್ನೊಂದು ಎರಡು ಪಾರ್ಟ್ ಇದೆ. I will mention those parts also. Please remember. This outermost cellular layer, which is rich in protein, it is called as aileron layer anta karitare. Outermost layer, which is rich in protein, it is called as aileron layer, and this part it is called as endosperm. Endosperm ಆಗೆ ಉಳಿದಿರೋದ್ರಿಂದ, since endosperm is retained as such, this kind of seeds are called as albuminous seeds. These kind of seeds are called as albuminous seeds, or also called as endospermic seeds anta karitare. So, and hence the answer should be A. So with that, we complete 2021 questions. Rachana, you are given the answer as B. I hope you agree that answer should be A. If you have any doubt, please let me know. So let us look into 2020 question paper. Though the question seems to be from second year, that is strategies for enhancement in food production, we can also consider this question as from the chapter called anatomy of flowering plants. So if you discuss, I think it will be helpful for both chapters. That is for strategies for enhancement in food production as well as for anatomy of flowering plants. Can you please give me the answer? Can you try to give me the answer? There are almost 20 participants from student side. Can you please try to answer this now? Yeah. So which of the following plants or plant tissues cannot be as used as explant in tissue culture? You know what do you mean by explant? It is a part of the plant which is taken for tissue culture. Tissue cultureಗೋಸ್ಕರ ತಗೊಳ್ಳೋ ಪ್ಲಾಂಟಿನ ಒಂದು ಭಾಗನ explant ಅಂತ ಕರೀತಾರೆ. Which means if you take explant and if you want to grow, or in other words, if you want to culture those tissue or cells, the primary requirement is it should undergo cell division. Cell division ಆಗ್ಬೇಕು. For cell to divide, it requires at least the presence of nucleus and also the cytoplasm. Nucleus ಮತ್ತೆ cytoplasm ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅರ್ಥ the cell is living. So all that you have to do is identify which of these cells are dead cells. See, I'm very happy that you people are trying to answer, even if it is right, wrong, or even if it is guess, doesn't matter. But don't do this for NEET. Don't guess it for NEET exam. In case if you are writing NEET, otherwise you just try to think. At least now I have given that this hint that ಟಿಶ್ಯೂ ಕಲ್ಚರ್ ಅಲ್ಲಿ ಬೆಳೆಸಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಸೆಲ್ಸ್ ಗಳು ಜೀವಂತವಾಗಿರಬೇಕು. ಸೆಲ್ಸ್ ಶುಡ್ ಬಿ ಲಿವಿಂಗ್. ಸೊ ವಿಚ್ ಅಮಾಂಗ್ ದೀಸ್ ಸೆಲ್ಸ್ ಆರ್ ನಾಟ್ ಲಿವಿಂಗ್? ದಟ್ಸ್ ಆಲ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಐಡೆಂಟಿಫೈ. Okay, so let's do one thing. Let's do like this. So, you know, entire plant tissues have been broadly classified into two types. One is called as meristematic tissue, which will be of apical meristem, lateral meristem, and intercalary meristem. And the other one, it is called as permanent tissues. So permanent tissues, it will be of two types. One is called as simple permanent tissue, and the other one is called as complex permanent tissue. Simple permanent tissue, it will be of three types. Which are those? One is parenchyma, which is living. Parenchyma is living. It will be having thin cell wall. It performs various functions such as photosynthesis, storage of food, floating of plants, etc. Second one is collenchyma. Collenchyma is also living. It will be having corner thickening. ಈ ತರ cells ಗಳಿದ್ರೆ, please remember the chemical. If there are cells like this in the corners, you can see a deposition of a chemical called as pectin. And then it is going to give some kind of mechanical support. And then collenchyma gives flexibility to plant's part. Leaf in a petiole nalli collenchyma irutte. Hypodermis of young dicot stem. Hypodermis of young dicot stem. It will be having collenchyma. And the last one is sclerenchyma, which is dead. Sclerenchyma is dead. ಅದರಲ್ಲಿ ಎರಡು ತರ ಬರುತ್ತೆ, ಒಂದು ಫೈಬರ್ಸ್ ಮತ್ತೆ ಸ್ಕ್ಲೀರಿನ್ ಅಂತ. It is dead. ಏನಕ್ಕೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅದರಲ್ಲಿ it will be having no protoplasm. Then what happens to protoplasm? Because the whole protoplasm, it will be replaced by a chemical called as lignin. ಸ್ಕ್ಲೀರೆನ್ಕೈಮಾದಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಲಿಗ್ನಿನ್ ಇರುತ್ತೆ. ಆದ್ರೆ ಕೋಲೆನ್ಕೈಮಾದ ಸೆಲ್ ವಾಲ್ಗಳ ಕಾರ್ನರ್ ನಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ ಪಿಕ್ಟಿನ್ ಇರುತ್ತೆ. ಸೊ ಕ್ವಶನ್ ಇರೋದು, ವಿಚ್ ಆಫ್ ದ ಟಿಶ್ಯೂ ಕ್ಯಾನ್ ನಾಟ್ ಬಿ ಯೂಸ್ಡ್ ಆಸ್ ಎಕ್ಸ್ಪ್ಲಾಂಟ್ ಇನ್ ಟಿಶ್ಯೂ ಕಲ್ಚರ್? Collenchyma is living, it can be used. Meristem, anyway, it is dividing, it means definitely it should be living, and it is the best explant for using in tissue culture. Best anta ಹೇಳಿದ್ರೆ meristem, ಯಾಕಂದ್ರೆ anyway cells are actively divided. Parenchyma is also living. Good. Sclerenchyma, it will be dead and it cannot grow. Answer agadre, it should be D. Yes, ಯಾರಿಗೆ ಎ ಅಂತ ಅನ್ನಿಸ್ತಾ ಇತ್ತು ಅಥವಾ ಬೇರೆ ಯಾವ್ದಾದ್ರು ಡೌಟ್ ಬಂದಿತ್ತೋ, ಐ ಹೋಪ್ ಯು ಪೀಪಲ್ ಹ್ಯಾವ್ ಅಂಡರ್ಸ್ಟುಡ್. ದ ಆನ್ಸರ್ ಶುಡ್ ಬಿ ಡಿ. ನೆಕ್ಸ್ಟ್. Next question is, match the following classes of fungi in column 1 with examples in column 2. So Phycomycetes, I hope you remember the other name for Phycomycetes. It is also called as algal fungi. Gamna ittu keliskolli. Don't try to answer right now. Don't try to answer it right now. Just listen to me carefully. ಪ್ರತಿಯೊಂದು ಫಂಗಸ್ದು ಇಲ್ಲಿ ಪ್ರಾಪರ್ಟಿ ಹೇಳ್ತಾ ಹೋಗ್ತೀನಿ. ಪ್ಲೀಸ್ ಟ್ರೈ ಟು ರಿಮೆಂಬರ್ ದಮ್. ಫಸ್ಟ್ is Phycomycetes. What are the properties of Phycomycetes? You know what do you mean by hyphae? The filamentous structure of the fungi. It is called as hyphae. The body, it will be called as mycelia, and mycelia, it will be made up of hyphae. Phycomycetes hyphae, it will be xenocytic, which means it will be multi-nucleated condition. I'm repeating, it is multi-nucleated condition. A condition ana xenocytic antare. It is aseptate. Adrartha cross wall iralla, and it is not branched. These are the properties of Phycomycetes with respect to its hyphae. Phycomycetes are generally required they generally require more amount of moisture, and hence they are found in aquatic habitat or moist habitat, and some of them are even parasitic. Some of these Phycomycetes are also parasitic. It produces asexual spores. ಅದು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡೋ ಅಸೆಕ್ಷುವಲ್ ಸ್ಪೋರ್ಸ್ಗಳು ಯಾವ್ದು ಅಂತ ಹೇಳಿದ್ರೆ ಅಪ್ಲಾನೋಸ್ಪೋರ್ಸ್, zoospores, and exogenous spores, which are called as sporangia or sporangiospores. ಮತ್ತೊಂದ್ಸರಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಇದು exogenous. So plus it do not show dikaryotic condition. ನಿನ್ನೆ ಹೇಳಿದ್ದೀನಿ dikaryotic condition ಅಂತ. Dikaryotic condition is absent because it will undergo plasmogamy, karyogamy, and immediately it will undergo meiosis. And example of such Phycomycetes, which is also an parasitic, is albugo. And it is parasitic on some of the mustard plants. Mustard ಗಿಡಗಳಲ್ಲಿ ರೋಗ ಬರ್ಸುತ್ತೆ albugo. ಸೆಕೆಂಡ್ ಒನ್ ನಿಮ್ಗೆ ಇಲ್ಲಿರೋದು ಆಸ್ಕೋಮೆಸಿಸ್. ಬರೀ 2 ಅಂತ ಹಾಕಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ನನಗೇನ್ ಬರೀತಾ ಇದ್ದೀನೋ ಇದು ಎಲ್ಲದರಲ್ಲೂ ಕಾಮನ್. hyphae, it is uninucleated. Hyphae is uninucleated. It is branched and septate. ಮತ್ತೆ ಹೇಳಕ್ ಹೋಗಲ್ಲ ಇದನ್ನ. It is true for all Ascomycetes, Basidiomycetes as well as Deuteromycetes. ಮೂರಲ್ಲೂ ಇದು ಕಾಮನ್ ಆಗಿರುತ್ತೆ. ಅದು ಬಿಟ್ರೆ Ascomycetes ನಲ್ಲಿ ಇನ್ನೇನ್ ಕಾಣ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ, you can see that Ascomycetes, some of the cells are unicellular, such as yeast. And one more example for Ascomycetes is penicillium. ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಯಾವುದು ಅಂತ ಹೇಳಿದ್ರೆ penicillium. Please remember this. Also, the other examples of Ascomycetes is neurospora. ಏನು neurospora the speciality ಅಂತ ಹೇಳಿದ್ರೆ, it is extensively used in case of genetic and biochemical studies. Neurospora, it is used in genetic and biochemical studies. Another example for Ascomycetes, ಈಗಾಗಲೇ ಹೇಳಿದ್ದೀನಿ, yeast is also an example. And edible morels, and truffles. Mushroom alla idu. Mushroom alla, edible mushroom belongs to Basidiomycetes. Morels and truffles, which is considered as one of the best, tastiest food, it belongs to Ascomycetes. Next is ಇನ್ನೊಂದು property Ascomycetes ನಲ್ಲಿ, it produces a fruiting body called as asci, or also called as ascocarp. ಅದಕ್ಕೋಸ್ಕರ Ascomycetes ಅನ್ನ sac fungi ಅಂತ ಕೂಡ ಕರೀತಾರೆ. The other name for Ascomycetes is sac fungi. Basidiomycetes is also called as club fungi, or even called as bracket fungi. Bracket fungi. Bracket fungi. Basidiomycetes produces a fruiting body. The third one ಬರೀತಾ ಇರೋದು. ಈ ಪ್ರಾಪರ್ಟಿ ಸೇಮ್ ಇರುತ್ತೆ. ಐಫೇರ್, uninucleated, branched and all. Basidiomycetes do not produce. Please remember, no spore production. Idralli, Ascomycetes ನಲ್ಲಿ it produces spores which are called as conidia. And these conidia are exogenous. Whereas sporangiophores are endogenous. I'm repeating, Basidiomycetes ನಲ್ಲಿ do not produce spores, but it produces a fruiting body which is called as Basidiocarp ಅಂತ ಒಂದು ಫ್ರೂಟಿಂಗ್ ಬಾಡಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಅದನ್ನೇ ನಾವು ಜನರಲ್ ಆಗಿ ಮಶ್ರೂಮ್ ಅಂತ ಕರಿತೀವಿ. ಅಣಬೆ ಅಂತ ಏನ್ ಹೇಳ್ತೀವೋ, ಅಣಬೆ ಅಥವಾ ಮಶ್ರೂಮ್, ಇಟ್ ಇಸ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಬೈ Basidiomycetes. ಸೊ ಎಕ್ಸಾಂಪಲ್ ಯಾವುದು Basidiomycetes ಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, Puccinia, which is also going to cause rust and smut disease ಅಂತ ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿರಿ. Rut and smut disease is caused by Basidiomycetes puccinia. Deuteriomycetes on the other hand, Deuteriomycetes on the other hand, they are called as imperfect fungi. Why they are called as imperfect fungi? Because they do not have an sexual reproduction is not either present, ಇಲ್ದಲೇ ಇರಬಹುದು sexual reproduction, ಅಥವಾ even if it is present, it is not known to us, ನಮಗೆ ಗೊತ್ತಿರಲ್ಲ. ಅದನ್ನ Deuteriomycetes ಅಂತ ಕರಿತೀವಿ. ಅದರಿಂದ imperfect fungi ಅಂತ ಕರೀತಾರೆ ಇದನ್ನು. Imperfect fungi ಅಂತ. An example for this is Q. I hope you got the answer. So 1 is R, correct. 2 is P, correct. 3 is yes, Q, 4. Answer should be first. Next question. This question is from Animal Kingdom. You know, Animal Kingdom has two large divisions. One is chordates and the other one is non-chordate. Chordateಗಳಲ್ಲಿ under chordates. Under chordate. You know what do you mean by chordate? On the dorsal side, it should be having and supporting structure called as notochord. It will be having a nerve tube or nerve cord. On the ventral side, you can see the presence of heart. You can see the pharyngeal gill slits and all. This chordate is divided into 3 groups. One is called as agnatha. Sorry, one is called as vertebrate. Among them is this one, vertebrata, and the other one is called as cyclostome. Under vertebrata, you can again see the further divisions of different groups. Now, those groups includes this one. So those which do not have jaws, they are called as agnatha, and that includes cyclostomata, which will be having circular mouth, and they are all marine or aquatic marine fish-like organisms. Q, gnatostomata, which will be having jaws, daude irutte. It is again divided into two classes. One is fishes or pieces, and the other one which bears limbs. Nalakku kaalgalirodrinda it is called as tetrapodon. Hagadre P should be agnatha, Q should be gnatostomata, R should be pieces, and S should be tetrapoda. So the answer should be B. Okay. Next question. Identify the floral unit I in the given floral diagram. See, I told you about different floral diagrams in last class. I don't know if you remember. Fabiaceal hengirutte, Solanaceal hengirutte. If I have not told you this, please remember this floral diagram is of a family called as Liliaceae. You know, not all, generally flowers will be having these structures. It will be having calyx, corolla, androecium, and gynoecium. It's part of it. These are called as petals. These are called as sepals. Sepals and petals belongs to orals called as corolla and calyx. In Liliaceae, what happens is corolla and calyx are both joined together. So Liliaceae family nal baro yaudadru lily flowers galna nodidre neevu ee thara flower idre, it do not have separate sepals and petals. Eradu separate iralla, but eradu fuse ಆಗಿರುತ್ತೆ. ಎರಡು fuse ಆಗಿರೋ ಯೂನಿಟ್ ಗಳನ್ನ they are called as tepals ಅಂತ ಕರೀತಾರೆ. Both of them together they are called as tepals ಅಂತ. Sepals ಅಲ್ಲ ಅದು. And the entire units of tepals is called as perianth. ಇದೆಲ್ಲದು ಸೇರಿ, all of them together. This, they are all same, arranged one row inside, another row outside. Adashtannu seri perianth anತಾರೆ. But each of this unit, pratiyondu unit anna, it is called as tepals. I'm repeating once again. Petals are the unit of corolla. Sepals are the unit of calyx. Similarly, tepals are the units of perianth. Hagadre I ಏನಾಗಬೇಕು? Can you give me the answer? B is not correct. Answer ಹೇಳ್ತೀರಾ? A ಅನ್ಸುತ್ತಾ ನಿಮ್ಗೆ? See again, please stop and start thinking and give me the answer. Do you think A? ಯಾಕೆಂದ್ರೆ ಅದು ಎಲ್ಲದನ್ನು ಒಟ್ಟಿಗೆ ಸೇರಿ ಪೆರಿಯಾಂತ್ ಅಂತಾರೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು ಆಗ್ಲಿಂದ. All of them together it is called as perianth ಅಂತ. But label ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋದು ಒಂದೇ. ಏನಾಗ್ಬೇಕು ಆನ್ಸರ್? ಆನ್ಸರ್ ಶುಡ್ ಬಿ ಟೆಪಲ್ಸ್. ಐಮ್ ಸಾರಿ, ಆನ್ಸರ್ ಶುಡ್ ಬಿ ಏನಾಗ್ಬೇಕಂತ ಹೇಳಿದ್ರೆ ಟೆಪಲ್ ಆಗ್ಬೇಕು, ಎ ಅಲ್ಲ. ಪುನೀತ್ ಚವಾನ್, ಭಾಗ್ಯಶ್ರೀ and others, no, A cannot be correct answer. ಮತ್ತೊಂದ್ಸರಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಿಮ್ಗೆ, ಪ್ಲೀಸ್ ಡು ನಾಟ್ ಕನ್ಫ್ಯೂಸ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಥಿಂಗ್ಸ್. ಇನ್ನೊಂದ್ಸರಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನೋಡಿ. ಯು ಹ್ಯಾವ್ ಓರಲ್ ಅಂಡ್ ಯು ಹ್ಯಾವ್ ಗಾಟ್ ಯೂನಿಟ್. ಓರಲ್ಸ್ ನೇಮ್, ಓರಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಎಲ್ಲ ಒಟ್ಟಿಗೆ ಸೇರಿ. ಓರಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಎಲ್ಲ ಒಟ್ಟಿಗೆ ಸೇರಿ. ಎಲ್ಲ ಒಟ್ಟಿಗೆ ಸೇರಿ ಏನೇನಿದೆ ಅಲ್ಲಿ? ಫಸ್ಟ್ ಒನ್ ಕೇಲಿಕ್ಸ್ ಅಂತ ಕರೀತಾರೆ, ಅದರ ಯೂನಿಟ್ ಸೆಪಲ್ಸ್, ಗ್ರೀನ್ ಕಲರ್ ಇರುತ್ತೆ. ಅದಾದ್ಮೇಲೆ ಬರೋದು ಕರೋಲಾ, ಅದರ ಯೂನಿಟ್ಸ್ಗಳನ್ನ ಪೆಟಲ್ಸ್. ಯಾವಾಗ ಕೇಲಿಕ್ಸ್ ಮತ್ತು ಕರೋಲಾ ಎರಡು ಫ್ಯೂಸ್ ಆಗಿರುತ್ತೆ, ವೆನ್ ಕೇಲಿಕ್ಸ್ ಅಂಡ್ ಕರೋಲಾ ಫ್ಯೂಸಸ್ ಟುಗೆದರ್, then that oral, entire oral is called as perianth. And the units of perianth, ಅದರಲ್ಲಿ ಒಂದೊಂದು ದಳಗಳನ್ನ ಟೆಪಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. Similarly, andrecium. Andrecium is the entire oral. Units of andrecium is stamen. It will be having filament and anther. Gynoecium, female reproductive oral, and units of those that are called as carpal. So ಈಗ ಇನ್ನೊಂದ್ಸರಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, do you still think the answer is A? ಇನ್ನು A ಅನ್ಸುತ್ತಾ ನಿಮ್ಗೆ ಆನ್ಸರ್? See, I don't want to leave behind wrong understanding. Adukkoskara, I want to make sure that those who are, at least those who are actively participating, you should not get confused. So answer for this, it should be tepals. Single unit and matra label madidare. Adrinda, see, again you are sticking onto the same option. You are still saying that option is A. No, answer is not A. Answer should be D. ಈಗ ಅಲ್ಲಿ ಎಲ್ಲದನ್ನು ಒಟ್ಟಿಗೆ ಸೇರಿ ಹಿಂಗೆ ಕೊಟ್ಟಿದ್ರೆ, ಹಿಂಗೇನಾದ್ರೂ ಲೇಬಲ್ ಮಾಡಿದ್ರೆ, ಇದು 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 ಎಲ್ಲದನ್ನು ಒಟ್ಟಿಗೆ ಐ ಅಂತ ಲೇಬಲ್ ಮಾಡಿದ್ರೆ ಅವಾಗ ಆನ್ಸರ್ ಪೆರಿಯಾಂತ್ ಆಗ್ತಾ ಇತ್ತು. ಬಟ್ ಹಂಗ್ ಕೊಟ್ಟಿಲ್ಲ ಅವ್ರು, ಹಂಗಂತ ಕೊಟ್ಟಿಲ್ಲ ಅವ್ರು. ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋದು ಬರೀ ಒಂದನ್ನ ಮಾತ್ರ ಲೇಬಲ್ ಮಾಡಿದ್ದಾರೆ. ಅದರಿಂದ ಆನ್ಸರ್ ಶುಡ್ ಬಿ ಟೆಪಲ್ಸ್. ಐ ಹೋಪ್ ಯು ಆರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ದಿಸ್. Next question. And probably last question. And let us do it very quickly. Quick ಆಗಿ ಮುಗಿಸ್ಬಿಡೋಣ. ಇನ್ನು 2 ನಿಮಿಷ ಟೈಮ್ ಇದೆ. A student observes grass and hibiscus plant in his garden during noon. With surprise, the leaves of grass were found rolled inwards. The reason could be. Grass ಅಲ್ಲಿ ಅದು ರೋಲ್ ಆಗಕ್ಕೆ ಕಾರಣ, when you say grass, grass is a monocot. So monocot leaf will be having a special structure which are called as bulliform cells. What is the function of these bulliform cells is, when there is more water, the leaf of this, it is going to become straight like this. When it has got less water, bulliform makes the leaf to roll like this. So grass, only grass it is going to roll, but hibiscus is not going to roll, because hibiscus is an example for dicot. And dicot leaves do not have bulliform cells. I am repeating, dicot leaf do not have bulliform cells. bulliform cells are present only in case of monocots, which helps in rolling of them. Hagadre, answer should be D. Please remember, rolling happens when there is less water. It will become straight when there is more water. Okay. So with this, we will wind up the class. Yeah, it's exactly 8. Let us wind
Yes,
up
sir.
the class.
Yes, sir. Right. Dear students, this completes today's biology. Sir, will you share the material?
Yes, sir. I will send this to you in WhatsApp.
Yesterday's and today's.
Yeah, it's the same file.
Okay.
The
Yeah,
same
got it. Got it. Dear students, wishing you very best of luck for your NEET exam tomorrow. Whoever is writing NEET, go with the confidence and write the NEET. I wish you all the very best for your upcoming NEET exam tomorrow. Thank you so much. Happy learning, students. Prepare well. And Monday again, tomorrow is holiday. Monday again, class will be at 4 to 8. Thank you one and all. Happy learning.